स्टार्ट कर लिया रिकॉर्डिंग? हाँ स्टार्ट की है। पक्का ना? ऊपर से ये नहीं है, रिकॉर्डिंग स्टार्टेड बट यहाँ पर वो आता है ना, वो देखो वो क्यों नहीं आ रहा है।
Six participants. So a very good morning to everyone. So from today we will start with the training for Sofistik. So basically Sofistik is just like any other finite programs that you use. For example, you all might be using stat, might as be used for them. What else you have used? Any other experience? Anyone? No, stat and sufficient. जैसा stat काम करता है, midas काम करता है, इसमें भी वही करता है. Any finite element program, what it will have is in the backend is stiffness matrix methods to small elements. Okay? You model big elements, but it will be meshed into smaller elements and you apply stiffness matrix method. So what is stiffness matrix method? Anyone can please tell me? Anyone? No? No idea? Okay. So basically you have got relationship wherein there is stiffness, displacements and the forces. Okay. So there is an equation you solve it displacements यहाँ पे लेके गए तो forces का stiffness का equivalent whatever you get. So I don't want to get into depths of it because we really don't need it in our practice. Okay. But that is the core of every single finite element program that functions. Any finite element program will have basic structure. That structure is you will have to define nodes. Okay. Between the two nodes, you will have to define the elements. Okay. Let us for now limit our discussion to beam elements. Elements can be of different types. That can be a beam element, that can be a quadrilateral element, that can be a triangular element, so on and so forth. Also the cuboidal. In our practice, what we need is mainly we work with these line elements and also with chord elements to some extent. We will be using chord elements as well. So you have got nodes, you have got line elements. Now, to these line elements, what you need to do is you need to assign cross-section properties. Okay. For cross-section properties, what you will need is materials. So the workflow is such that from one side you start to define nodes, you define your structural elements, basically you develop a geometry. You define materials, you define your cross-sections, assign your cross-sections to the elements that you are modeling. Okay. Once that is done, what you need to do is assign boundary conditions. Once boundary conditions are assigned and your structure is stable, then what you do is you apply loads. In order to apply loads, you need to create boxes named load cases. Once you have that, what you further do is your work is done. Rest all is work of the program to perform analysis. In analysis also there might be different complexities, linear analysis, non-linear, geometric non-linear, material non-linear, first order geometric non-linear, second order geometric, so on and so forth. We don't want to get into those discussions at the moment. Once that is done, it performs analysis for us. As a user, what you need is final results. As structural engineers, in practice, what we mainly look forward is for shear forces, bending moments, and axial forces. We extract those results, we take those results from there, and we use our design methodologies as per our codal provisions, and we go for further design. So this is the workflow. You take Sofistik, take Midas, take Stat, any program. This is the. I work with a very fancy program named OpenSys. Have you heard of it ever? Also, OpenSys. So it is highly used for very non-linear incremental dynamic analysis with non-linearity with gap models and this and friction pendulum bearings and all. उसके लिए भी when I went to my professor, I said, so Sofistik has got a nice graphical user interface. If there is an error, Sofistik returns you an error stating that there is problem in so and so line. OpenSys is such a thing that it won't give you any error. It will simply, it's a black window that just simply closes down. But that is widely used in research domain. Reason is it has got very high capabilities to handle the non-linear stuff and all. But when I went to my professor and said, I cannot really deal with these codes and all, then he told me this story. Any finite element program that should have nodes, should have elements. So you start with definition of nodes, elements, material definition, cross sections, assign cross sections to it, ज्योमेट्री अच्छे से बना लो, उसके ऊपर अच्छे से लोड्स लगा लो, तुम्हारा काम खत्म हो गया. What you need to further know is only interpretation of results. Clear? So this is going to be simple workflow for Sofistik as well. Now you will say, why Sofistik? So say why Sofistik?
No, we know why.
Why Sofistik, right? But I'll just
We are
put it in
convinced, huh?
2 lines. Is that it is customized. Every program will be customized for different users. Sofistik is, has got some abilities and functions and all. It is customized for our use. That is for, bridges and interest, which makes our life easy. That is all. Now let's just get into, modeling of one simple beam problem. Then we focus on modeling of this particular post tension curved simply supported bridge. Okay. And we won't use the methodology that we used in our workshop. We would go with the AutoCAD references. AutoCAD references stands for, we have got drawing something like this. You take reference of those center lines here like this. Okay. Assign those cross sections to those center lines and develop model very quickly. If you learn this particular method, you can develop any model of any kind that comes to you. Okay. But just do this, understand the principles of this one thing. And that has been my experience that, you will be able to handle Sofistik very efficiently. Once you understand the entire workflow for this, so not only, modeling the geometry, but also the live loads, the combinations, extraction of results, generation of the report, the entire workflow. Then comes the next step, wherein you go for axis-based modeling and the automation that we were looking at. Okay. Once you are done with that, then comes the next step that you have Excel and TED, and then, combine it and, you get, automated stuff going on. Then comes a level that you open Revit, develop your models in Revit and use Sofistik for your further analysis. Then further comes a step that you use as pre-processing unit Rhino and Grasshopper and, develop your models. So there are steps to it. But if you do this, this is more than sufficient for any bridge engineer in practice. One really need not, look at the rest of the ways further. Okay, that is what I'll say. In my practice, I use this method and almost, except when there are, repetitive modules, this is the most preferred way, right? नहीं तो ऐसा होता है कि ये मेथड को यूज किया जाता है AutoCAD रेफरेंसेस से और बाद में जब आइटरेशंस जब करने का जब जरूरत पड़ती है तो ओ वी शुड डेवलप एन ऑटोमेशन. So let's have a look at it. Let's first go for a simple beam model, get your hands on it, and then we start with this very quickly. Okay. But we need to really complete this within, I'll say, today and tomorrow. And day after tomorrow, we should go on to more into TED, parts of automation and all. This is what I planned. Okay. Let's just move further. So I'll just create a new folder and I'll say training day 1. Okay, so maybe you can also create the same folder and copy this path, Control C. Sofistik model, it is recommended to always create a new folder. The reason being there will be many secondary files getting generated. So which will be stored in one folder that would act as a database. Okay, so what I now do is I go right click and I say simple beam model, simple beam, and I'll give it a name R0. Sorry, the revision number as R0, simple beam dash R0. So I get into it and I just copy this path. Please copy this path. Okay. Now I go to search bar here and type in SSD just to start this Sofistik 2025. Okay. So I start with SSD 2025 and I say new project. And then it asks me where to save this. So I click on this folder here. Okay. So basically I browse for my folder and I paste that path and I say save. It takes me to that particular folder of simple beam R0 and I give it a file name simple beam hyphen R0 and I simply save it. Once I save it, what you can see is you can see that the entire path and finally the name of your file simple beam dash R0 dot sophistic. Dot sophistic is an extension to it. Title. Title is something that appears on top of your report, on each page of your report, basically. So you should give it carefully. Maybe, for example, what I would do as a practicing engineer is my span is from P35 to P36, something like this, just to identify what it is. इनफैक्ट जो मॉडल है यहाँ पे मैंने सिंपल बीम डैश R0 जो डाला है मैं उसका भी नाम डाल सकता था P35 dash P36. So that is the span that I am going to. This model stands for that. So I go to IS and I select IRC112. System is three-dimensional. Gravity direction is negative Z. Basically, upward Z is, Z is in the upward direction. Gravity will be in the downward direction. Groups, I keep it as fixed and group divisor is 10,000 for now. So we will come to this discussion what is 10,000 group divisor and all. If you want, we can discuss it later, at the time of construction stages and all, not now. And I am setting my units to structural engineering, wherein my sections will be in millimeter and my system will be in meters. So when I say this, my system will be in meters means the length of my girders will be part of my system, that environment. That environment will be, it is always good to say 30 meters than 30,000 millimeters. But when it comes to my sections, section modular is a different environment wherein you will be mentioning 2000 millimeter depth of my girder, 1500 millimeter depth of my girder, so on and so forth. Okay. So I select the structural engineering sections in millimeter and system in meters and I simply say okay. And I simply say okay, I do nothing else and Sofistik opens for me. As soon as this opens, okay, there is something called viewer. You see that here is at the bottom is the window that you see is the window for the viewer. Okay. If you click on this system, okay, another window will open at the bottom. You see that it is called system visualization. So I'll tell you what this viewer is and what system visualization is. Okay, after having looked at WinGraph. Okay, earlier until version 2024, once you open SSD, you directly get into system visualization here. But since 2025, this viewer is coming up. I'll give you the reason for that as well. Now, we would want to model a simple beam. Okay, so this is SSD, something called Sofistik Structural Desktop. Here at the top, you can see 2025. Okay, and there is also name of our, so here there is name of our project file. Onto the top, there are different tabs: Home, System Visualization, Images, View, Help. Home is a tab wherein you can perform different functions over here. You can go to, you can perform calculation from here. You can go to different, interfaces. That is, first is system visualization. Okay, so this one, the second one now I'll say, wherein you can see your behavior of your structure. Okay, but not the numbers associated with it. In order to see the numbers, you need to go to something called WinGraph. Okay, and there are results means you will get in the tabular format the output, and report is something you get in the report format, the A4 sheets. System visualization. Okay, let's just simply start working and we have a look at all these tabs. Onto the left hand side, there is project navigation tree. Okay, the first task over here is, so these are all called different tasks. Okay, so as I was discussing, the first task is to define materials. So you can define materials from here. You can define cross sections from here, but you cannot define any geometry over here in this SSD. It has got no capability to define any geometry. So in order to define geometry, Sofistik has got a pre-processing unit, which is called Sophie plus X, which is AutoCAD based graphical user interface. Okay. So in order to define geometry, what I need to do is I need to get into this, step into this Sophie plus X. Okay. So I just double click on that and my Sophie plus X opens in the background. Meanwhile, as it is opening, what I'll do is I'll just give you a brief of this project navigation tree. Further, once you have defined this model in the pre-processing unit, you export that model to this place because the pre-processing unit doesn't have capability to perform the analysis. Analysis will be performed by SSD. Once that is done, what you do is you want to further perform linear analysis. So there is a task over here. You want to go for construction stage analysis. There is task over here. Further, you would want to go for different things. For that, you need to simply do right click and say insert task. And there are different tasks available. For example, you have got a geometry already model and you want to go for, let's say you want to go for eigenvalue analysis, the model analysis. You need to double click on this task. A task gets added over here and you can, there will be, double click on this and just get into it and say, I want 6 eigenvalues. I want to use so and so method, so on and so forth. Okay. So I'll just delete this task. So you can add, you can insert new task. You can change sequence of the tasks. In 2025, I think this is a problem. So until now, what was there that you could change the sequence? You need to simply select the task and change the sequence and all and all. If you right click on any task, you will be getting this option to calculate that task. Okay. If you right click on cross sections, you will get an option to calculate the task. Also, you get the option that calculate up to cross sections and calculate from cross sections. For example, if I would want to calculate only, the tasks below cross sections, then you need to only calculate that. You don't need to run the entire model every time. That is the idea. If you have got model geometry already developed and you want to run only the live loads, then only that you need to go to live loads and say that you need to execute only live loads. Yeah.
कैलकुलेट क्रॉस सेक्शन कैलकुलेट ऑर्टिकल्स मतलब क्या हो इसमें क्या कैलकुलेट
उसमें क्रॉस सेक्शन की जो प्रॉपर्टीज है प्रॉपर्टीज आते हैं. And what happens is, in simple words, if I say, let's say I say calculate cross sections. So there is no cross section at the moment. So let me add one cross section over here. So I do right click and I say new rectangular beam. And I simply added it here. Okay. As I say calculate cross sections. And again, I go back here and I say reports. Once I have calculated, only then I'll get this. Before this calculation, I don't get any report. Here also you see that the report is of 3 pages. Okay. Now if I go back to cross sections and I say edit and I say that full text output, okay, to the report and I say okay. Now if I go to reports, my output is of again 3 pages. If I now go back here and I say edit and manually controlled cross section, normal output, picture properties, no output. Yeah, I keep it this way. So it is 1 page report now for the cross section and that is sufficient usually. So what I want to say is that every task has got option for calculation. In every task, you can limit the report output number of pages that you are getting, the extent of output that you get. So that in the later stage, what you can do is you can go to these reports and here you say that configure custom reports. And then you will start to add that, in the report, you want to have materials, you want to have cross sections, you want to have this, and automatically your entire report will be generated. This is the idea. This is the workflow. Okay. Now, what I do is I already have the Sophie Plus X opened here at the backend. Okay. And this is an interface which is based on AutoCAD. Absolutely. If you look here at the top, all of the tabs are as same as our AutoCAD has, normal AutoCAD. It can perform all functions of AutoCAD. Okay, it is an AutoCAD only. But in addition to AutoCAD, what it can do is it can give a structural sense to our AutoCAD objects. For that, there is a ribbon menu over here onto the left hand side, wherein you can define materials, you can define cross sections, and you can start assigning those cross sections to your existing AutoCAD reference lines. So you might have used E-tabs. In E-tabs, if you remember, there are grids. You first start with the grids, then start assigning structural elements to those grids. I don't know whether you have used or not, But similarly, the reference lines, AutoCAD would only give the reference lines that I'll just show you. Okay. Now what I do is here, my default materials are M20 and FE500. If you want to change your material, let's say you're not interested in M20 grade concrete, what you could do is you can simply double click on it and simply say that classification you would want to go for M40 grade concrete. And you simply say okay. If you want to define a new material, okay, what you can do is you can go to materials, do right click and say new material from design code. Same dialog box, same form appears, and you simply say that now you would want to go for M45 grade concrete with kind of cement that is normal hardening. Okay. And you simply say okay to it, and a new material is added. Further, now you're not happy with this M45. You simply say that you want M45 grade concrete, but you don't want it say of the density that has been currently defined. So what I do is I go to this M45, do right click and I clone it. Clone is duplication. It asks me for the next ID and I simply say okay. So I got material number 3 M45 grade concrete and material number 4 as well as both are M45. I double click on it and I click in this general properties, this tick box, and I say that my gamma value, I would want to keep it 0. And as a result, I'll also change the name, the title here saying that M45 0 self weight. And I simply say okay. Everything else remains same except the unit weight is now altered. Okay. So this is how your materials work. In Sofistik, there is possibility to define many materials, soil, structural material, building material, fluids, synthetic materials, so on and so forth. You see that there is big library. Okay. So if any user is interested, one can go for it. But for structural engineering applications, this is really, hardly required any times. There are many different materials like yeah, so I don't want to get into depths of it at the moment. Now, so the materials are done for the moment. We go to the cross sections. Okay. In cross sections, you simply go to new standard section. You have got this option, or you have got another option, new solid section or new thin wall section. These are the three options available. In new standard section, you have got a rectangular beam, rectangular column, T-beam, plate, wall, edge beam, shear wall, and circular and elements and steel profile. So these are very simple elements which are really insufficient for a structural engineer to work in the practice. Okay, we need for example, I got an eye girder, PSC eye girder that I was showing you. Okay, that is not possible this way. So in that case, what I need to do is I need to go to new solid section wherein a new environment opens named cross section editor. Okay, so I'll first show you how new standard section works. So I'll again go on this rectangular beam. Okay. And in rectangular beam, you can update the name, you can update material, reinforcing steel, so on and so forth. If I change the width to 500 mm, let's say, automatically my title also gets updated. Comes, reinforcement options, lower side and so on and so forth. So I simply click OK. And to my surprise, this 500 by 800 is not updated. Maybe I can update it manually. And I simply say OK. और है आपका 24 है क्या सर 25 ओके ये नाराज है फिर मेरे से the moment you click on this calculate all, you can see over here at the bottom. Okay, you can see here at the bottom, you see here at the bottom numbers associated with your cross sections. Okay, you see that, or what you can do is you can simply press F2, press F2, run calculations and press F2. तो कहीं पे क्लिक करके करना है मैं बोलता हूँ फिर I repeat. So you need to go to cross sections, do right click and say calculate all and just press F2. So maybe you need to press function F2 in your case. So you see that for cross section number 1, it will have calculated all its numbers associated with it, all cross section properties. Okay. Now I would want to define another cross section, which is like this, which looks something like this, here like this. Okay. In that case, the standard sections won't work. Okay, so for that, you need to go to sections, right click and say new solid section and say reinforced concrete. Okay, let's say I say reinforced concrete and I give it a name midsection. And I select my material as M40 grade concrete, reinforcing material as Fe500, and I keep my beam type as eccentric beam. There are second tab for analytical parameters to which we do not touch. Additional properties we do not touch. Reinforcement layers we do not touch. Stages we are not going for construction stage analysis for this simple beam problem. And this is just I'm giving you the background. You may not work on that simultaneously. So you will be doing it yourself as well. And there are variables. If you want to vary the depth of your cross section along the length of your structure, then that is possible. But currently we have got only one option here, only one tab touched, and I simply say okay. The moment I say okay, I enter into entirely a new environment, which is called cross-section editor. You see over here at the top. This looks similar to what your Sophie Plus first environment was, but this is not that same. In that first environment, you model the geometry. Here you model your customized cross sections. Now, in this, if you see here at the top, it is cross section number 3 and midsection and drawing units are in millimeters. Okay. If I now suppose have a rectangle like this, if I have AutoCAD geometry, a reference geometry already available with me, which is a rectangular geometry like this, then if I go to this option, solid cross section, and if I go to this boundary, okay, click on this boundary, and if I select appropriate material, which I want from here, and give it appropriate construction stage, if you have at all defined the stages, then you need to simply pick these vertices. And close down this dialog box, press escape, and your new cross section is now modeled. And you need to go here at the top right corner and say calculate these cross sections. The moment you do that, your cross section is calculated, and here you see that the centroid is identified. Okay, shear center is also identified. You see C and shear center here, SC. Here you see that this is a stress point, okay, at the farthest corner points, okay, in the cross sections. These are defined by Sofistik. If you press F2, again, all the properties associated with these cross sections, the numbers are available with you now. Okay. Now, what you further do is, this was a very simple cross section. Okay. Very easy, only 4 data points. I'll just delete it. Okay. Now, what I further do is, use of 4 points was, difficult for me. So I go for this option in which I say you can use this option rectangle because it's my rectangular cross section, right? So I click on this rectangle, just select this top left coordinate and the right bottom coordinate. Then also I can model this same cross section. You see that it is the same cross section, same output you will get. But I'm lazy to do that as well. So I'll just delete it and I'll say I want more efficient way to do this. So I go back to this definition of boundary, and from here, instead of pick lines or curves, instead of rectangle, what I do is I go for point in area. So I click on point in area, and now I selected that option and I just click inside this. So whatever is bounded inside that area, that becomes a cross section. This is the idea. Now, how it makes our life easy is I'll just show you. I'll delete this entire cross section and I go back to this my AutoCAD file. I'll go to the model space, and here in millimeters I already defined one cross section. Same cross section मैंने उसको scale up करके रखा है यहाँ. So basically this is in meters. थोड़ा geometry दिख रहा है और यहाँ पे ये millimeters में. मैं क्या करता हूँ? I'll just go and select this cross section. I'll say Control Shift C. I'll specify a base point. So I need to switch on my objects snap options. Okay. So I selected this. I'll do Control Shift C. So I'll select a midpoint over here. I'll go back and I'll say Control V and I'll say 0, 0, enter. This has come upside down. The very reason is my UCS here is upside down, but this is just an AutoCAD reference. So what I do is I select it, I say mi enter, which is mirror command, and I just draw a line like this, and I'll say yes, erase my source object. So now this is my reference geometry. I go to my boundary here. I select the appropriate material, whatever I like. I select appropriate construction stage for, in this case, my girder, and I say point in area, and I just go and click inside this, and my cross section is generated.
So only girder will be generated, not the composite.
नहीं, वो मेरे को अलग स्टेज में डालना है ना, बाद में उसको एक्टिवेट करना है. अगर ये मेरा सारा एक ही पॉलीलाइन रहता तो मेरा सारा जनरेट होता ऐसा. Now, also, if instead of that, so it's there in the back end, okay? So you need to do this draw order and bring it to front. You know that layers thing. Now, if it was suppose a box cutter, curvatures and all, you need to simply bring it from your AutoCAD, keep it over here, say point in area, and your geometry, cross-section geometry is ready. Now you want to get numbers for this, go at the top and say run calculations, and here you will have numbers on your screen. So my cross section area is 0.727 meter square, so on and so forth. Okay. So any cross section here on in future, let that be steel or let that be concrete. That can be modeled over here. There is absolutely no bound for that. Okay. You will be doing that yourself. When we will be doing our PSC composite system, in that case, what difference will be? Let me just tell you that as well right now, so that it will be easier for you. In that, I'll have to activate my cross section in stages. My girders come first in the first construction stage or second, whatever first when it comes, and my flange gets activated in the later stage after my composite action is mobilized. Okay, only after my deck is casted. In that case, you say new stage, and let's say stage number 10 is girder activation. There is one more stage. Let's say that it is stage number 100. Then I say that it is flange activation. And I simply say, okay. Now I go to my boundary and I select my material as M40 grade concrete for my girder. And I say that I would want to activate it in stage number 10. And I say now point in area, and I simply click on this. When it comes to my now definition of this, I would want to have material which is M45 grade concrete, but zero self-weight in this case, because I'll be using the self-weight of the deck slab that I'll be modeling later to get exact weights or the loads for that. And I say that I'll activate it in stage number 100. And I just click inside this, which is point in area. So this cross section in your construction stages will be activated in two stages now, the bottom first and the top later, so on and so forth. If you press F2, you will get, separate numbers for the girder, separate for the flange, and both combined together results as well you should get. So I just close this down. So I just save it. So this was definition of the cross section. Okay. When it comes to steel sections, okay, users prefer modeling the thin walled sections. Okay, this was solid cross section. But if you go to cross sections and you say new thin walled sections and you go to, let's say it's your steel, okay, steel, and I give it a name, some profile, let's say I. Here also you can define different materials. So I have not defined any material for steel. So I can define new material from here itself as a shortcut, and I say okay to this. And I can give stages and all, but since it is just a demonstration, I simply say okay. And here then you get an option to define boundary. Okay, sorry. Thin wall cross section element. So you can define thickness. Let's say my thickness is 12 mm. Okay. And then you could simply start to model an I section. So something like this. So let's say it is 500 like this. Okay. And the depth is let's say 600. And what you can do is you can simply CO enter, copy it from here to here, and your I girder cross section is defined. Okay. You can define it in more sophisticated ways. That means here is an overlap, then you can bring it here and connect with the welds and those, shear links and all of that. Okay. I don't get into depths of it for this particular training program. Oh, so your cross sections you're okay with. So any cross section, any shape, you should be able to do that. So if I go to this, there is also an option for opening. Okay. For example, I would want to go for example, I would want to go for a hollow beam here like this. Okay. So there is something hollow here like this. Okay. So this is a structure which is hollow over here. Then I can simply go to opening and I can simply say point in area, and this is an opening now. So this is my hollow cross section. I just give it a run and just close it down. Simply say save. That is all. If I want to update my cross section from mid section to end section, let's say, okay, I do not define everything from scratch. Okay. I go to mid section and I say clone my section. What happens is that only my web thickness increases, right? So I say clone my section and I simply say okay. I double click on it. I say cross section properties and change first of all its name to end section. So it is cross section with ID 4. I simply say okay. And in this, I would want to go for my this thing, this one, right? This width, Control Shift C from here, bring it to this. Again, it is upside down. I just mirror it. Okay. And what I can do is now I can smartly only drag these vertices from here to here. I don't need to define from scratch. Okay. So this is my new cross section now. I give it a run again. This is my cross section, end section. And I simply close it down.
Just one question here.
Yeah.
Now ये tapered section बनाएंगे इसके बाद इसका. तो like matters में क्या होता है in the say section at I and J end, the number of nodes cross section should be equal. तो यहाँ पे ऐसा नहीं.
यहाँ पे भी है.
यहाँ पे भी है. यहाँ पे लगते हैं.
मैंने चेंज ही नहीं किया ना, मैंने बस ड्रैग किया.
Just drag.
और इसलिए मैं ये जो स्ट्रेटेजी इसलिए फॉलो करता हूँ कि अगर मैं नया पॉलीगॉन बना के मेरे को पता नहीं वहां पे कितने वर्टिसेस होंगे, कितने पॉलीलाइंस होंगे. If I use this strategy, then my number of nodes are ensured ये सेम है. और मेरे को पता है कि मेरे को यहाँ से यहाँ तक ऐसे इंटरसेक्ट करना है, वो नोड वहां पे ही रहता है. Never make mistake with it otherwise. So what I now have is, if I go to SSD, you can see that my materials and cross sections are updated 4 in numbers without my export. अपडेट नहीं हो रहा है. नहीं, आप में तो उतने हैं ना. हाँ, सेव करने में. तो मैंने अब तक ज्योमेट्री नहीं बनाया, मतलब मैंने मटेरियल्स और क्रॉस सेक्शन सिर्फ मॉडल किया है. अगर मटेरियल्स और क्रॉस सेक्शन ऐसी चीज है कि जो वहां पे जो दिखते हैं वो यहाँ पे ऑटोमेटिकली अपडेट होती है. ज्योमेट्री ऐसा नहीं. ज्योमेट्री एक्सपोर्ट करने पे मेश होती है, फिर यहाँ पे आती है. नाउ if I go to these cross sections, right click and I say calculate all cross sections. And if I now go to the reports here, then I have got a nice report of my cross sections. Whatever 4 cross sections, you 3.1 for that, different thing. But it is only one page reported. I'm not happy with it because there are no graphics and visual cross section things. So I say edit and I say full text output. And I simply say okay. And now I go to the reports. If I just scroll down, you see that now I got cross section, this, that, everything will be there. Yeah. So you can set this output as you want. This is a hollow cross section, something like this. Very weird, but yes, it is possible to define. Yeah, I just close this down. So this report finally you'll have to present in your, as submissions and all. Now, moving ahead, I had no intent to get here into SSD right now. Module that is used in the background, okay? The name is Aqua for this material definitions and cross sections. Just keep the name on your mind. We don't want to get into the depths, but this is important because when you start using Teddy, that time to define materials, you'll have to first tell that now activate my module named Aqua. so that I can define in one single line, all these cross sections will be defined in case of trading. What our next step will be to define a beam element. What I can do is, here you see that this was system definition, wherein the first tab is system definition here on the left, wherein you can define materials, cross sections, bore and soil profiles. Work laws means, springs, force versus displacement relationships. The pre-stressing systems and the axis, all these can be defined from here. It is system definition. Then comes the next tab, which is structural elements. Okay, wherein you would want to define where your geometry, then you need to go to this tab, second tab, wherein, as you know, that node is a point element. So in order to define node, you will have to select that point and just click over here somewhere inside the model space to generate the point by giving it some, first information like node number, is that, what support if there are conditions in it. If you want to define line, okay, then line element, the beam element that we are going to model, that will be done using this line element. Okay. For a line element, the prerequisite is that you need to have nodes first. Next is the area element here, which is thickness. It will ask you for, so on and so forth. In the line element, it will ask you for what cross section you would want to define and all. Then comes, storage and tower definition. This is for basically building industry. So let's not discuss much about it. Manage groups and numbers. Group numbers, you want to renumber and all, that is possible from here. I personally don't use it many times. Find and align, if you want to find some element number and want to align it to something. So this is one of the options. So splitting, union, this, I don't use all this. Parametrics is a very important thing when it comes to the automation and all. We are not going to parameterize anything now, so we don't touch here. So for us, at the moment, we have got point, line, and area. These are the three important things, the buttons we have. Next tab is for load definition. Okay, let's first model our beam element and then go to the load definition. Okay, so to model a beam, it is my line element. Okay, this is how now Sofistik is different. I straight away go to line element. I go to general tab and I go to group number. I say that group number is 1 is okay with me. I go to next tab, which is beam oblique cable, and it asks me to select the cross section. So I say that as cross section. Okay. And it asks me to select the start section and the end section from here. For now, I'll keep start and end section both as mid section. Okay. And I do nothing else. I simply get into my model space and I start with any point anywhere in my model space and I simply drag a line here like this. Okay, any line. I'll switch on my ortho and draw a straight horizontal line like this. Okay, which should be approximately of 10 meters. So I'll just say 10 meters, 10, enter, and I say escape. So I have modeled a line with cross section, mid section, and I just have drawn a line. And now I go to from 2D wireframe view to conceptual view, and I get to see something like this.
ये माउस वाला क्या सिस्टम है?
अच्छा, आपको अगर उसको रोटेट करना है, देखो सिर्फ आपने ये स्क्रॉल ये किया तो ये आगे पीछे शिफ्ट होगा. शिफ्ट दबा के अगर उसको किया तो ये सब गोल घूमेगा. क्या देखना है आपको? Conceptual view. So whenever you perform any modeling and all, it should be done in 2D wireframe view. But if you want to visualize your structure, what geometry has been assigned and all, then you need to go to conceptual view. It is a better visualization, nothing else. Now, what we do is, our next step is, if it was any other program, you will have to first define two nodes. Then you will have to define the element in between. But in Sofistik, it is not that. In Sofistik, you can directly draw a line, because here for Sophie Plus, it is still on structural elements level. For it is one element now. But when you will export it, that time it will break this particular element into smaller pieces of whatever 1 meter length, 0.5 meter length, and all whatever the automation options are. And it will create nodes right from start to end and many nodes in between. For example, I'll just say that export this one, export create calculation model. Basically, I have not assigned any support. I'm not going to perform any calculations, and I simply say OK. So it has exported my model. It goes to SSD. In system visualization, you can simply see that. You see that here. Okay. It was one straight line, but now it is broken down into these small elements. And if I just say here, I click on this, and this is beam 10,001. Okay. The name of this element is beam 10,001. Cross section at start is 3, at end is 3. Node number 1 is here, node number 2 is here. If I go to the next one, then it is 10,002. This is 10,003, 10,004, 5.
कैसे divide किया? We did not give any input. These many elements या फिर this the length.
So the thing is, when we exported it at that time, it says that determine automatically. Okay. Or you could set manually 1 meters. That was your choice. But Sofistik recommends this option, determine automatically. It runs an algorithm in the backend, and जहाँ पे फिर आपका junctions है वगैरह वहाँ पे finalize करता है वगैरह.
Say we define different element cross section at different points. तो automatically
लेगा. और ऐसा है कि suppose, for example, if you have now another line element that goes from, for example, this only, I'll say CO enter. I'll just copy it in the same plane. Ortho on इसलिए I'm very sure about it is in the same plane. And I just go here from here to here. And if I just export it, so these two are connected. So a node will be generated automatically here at the intersection.
Can I see the nodes? Yeah. अलग से nodes वैसे वो
वहां पे node को बना देगा इधर.
Okay.
So idea is that if there are two intersecting points, two intersecting lines, if there is intersecting area with the line, so on and so forth, you don't need to be really very careful about the connectivity of the nodes. For example, to analyze the foundation in STAD, for me, I create a column and plate element for that foundation and many springs below. Then I'll have to be very careful about the node connectivity with my column and this and that and the piles and coming up and all. But in Sofistik, you don't need to really worry about it. Just draw in appropriate planes the vertical element, the plate element, and the pile elements. I got those models already ready. I can show you. You don't need to really be worried about your nodes and all that. So that really helps a lot.
Column can be a single line element.
Yeah.
Footing can be a plate element.
Yeah.
And उसको different periphery पे nodes से I need not connect.
Yeah, you don't need to.
Sofistik.
यहाँ पे भी उसका
periphery आ रहा है connect. वो rigid link या elastic link जैसे भी वो बन जाए.
So this is one of the major advantages, especially when your structures are really big and all. Yeah, so let's just proceed. So this was one way of modeling a beam element. Okay, if I go to the conceptual view, it looks something like this. This is a way wherein you don't have any reference. I modeled a line at some place in my model space, which I really did not know where it was. And I'm really not happy with it at all, frankly. What I can do is I can take a controlled approach. Okay, so I just delete this. I go to the wireframe view. I go to the line here. Okay, same things, everything the same. And the controlled approach can be, I go in the model space and before hitting anywhere, okay, I say that it says pick first point. So I said 0, 0, enter. So its first point is now picked. Okay, this is my controlled approach, you see. Instead of modeling a line anywhere, I did it at this. And it further asks me, specify first point or select these objects or it asks me for the length, I think iske baad, yeah, 10 meters. I said the length and it's now straight line that starts from my origin and goes for 10 meters. Okay, this was the controlled approach. Okay, now what else I can do is, okay, this is one thing, but what I can do is I just delete it. And let's say that I have got an AutoCAD line. Okay, I have an AutoCAD line. Okay, which is, furthermore a good reference for me. So I say L enter, which is my AutoCAD line, and I specify its first point as 0, 0 and length as 10 meters. And this is my AutoCAD line now. Okay. And now what I can do is I can go to line again. I can go to as cross section. I select cross section number 3. I go to model space and I say this option, pick lines or curves. If you're not able to see this option below, what you can do is you can right click and select it from here, pick lines or curves. That is also a way. And now I go and just hover over on this line and I can simply click on it and the line gets selected. You see that? You see that? So the idea is if you have a geometry, okay, which is predefined. For example, you have got AutoCAD drawings, concrete dimension drawing is okay. In that case, you already have such kind of lines already modeled. You already have those references. You need to simply go and click on those references to be able to generate such kind of beam elements. This is the idea. This is called modeling based on AutoCAD references. What you learned in the workshop yesterday was not this, right? It was based on an axis, and every time you don't really need to create an axis. No, I don't like working on axis unless and until I have got automations to do. For example, what I do is it is not necessary to go for such kind of thing. So what I do is I go to the 2D wireframe view, and now I say ARC, okay, and I specify my base point at 0,0. I give its length as 10 meters again, and maybe I got an arch like this, third one, okay. And I go to line, I go to as cross section, I go to mid section, and I say pick lines or curves, and I simply go and pick this, and it is my now curved beam. If I export it, activate my these cross sections, something like this. It is too much of curvature, bad, but if the curvature was less, 10 meters में इतना ज़्यादा curvature डालना सही नहीं है, but it works fantastically. Especially in the cases when there are, these days curved pylons of this shape, that shape. Instead, what you will have to do is you will have to go for more number of nodes to obtain that, finer, accuracy. But in this case, you don't need to really care about if it is such kind of Namaste pylon was, one of the examples that I was doing last time. So it was shape was something like this, and I have to simply, select that AutoCAD line only once, and automatically that shape was, selected, something like this. Now what I do is I'll just show you an example wherein I have got this, geometry already defined here like this. This is my AutoCAD reference. I say Control Shift C. I select this 0,0. I go here, I say Control V 0,0. This is my AutoCAD reference now already. Okay, so I should be working in the wireframe view. Okay, now what I can do is I can go to structural line and I simply go select cross section. I select my cross section number 3 and I say pick lines or curves, and I just go on to pick these lines. You see, and I go to the conceptual view and it looks something like this. I'm not happy with this because it should be a tapered section here, right? So what I do is I want to modify it to the end section. So I say apply, and you see that now it has to be tapered. So my first I coordinate should be end and the later one should be mid. And I say apply. It is updated. Further here as well, from mid to end and from end to end. You see that? What you can further do is you can simply copy this girder from this to this. For example, if I go to the conceptual, select this, I can select it all at a time as well, but I did not want to select that AutoCAD geometry. That's why I just chose to select it like this one by one. And what I can further do is I can say CO enter, which is copy command, copying from this base point to here to here. So it's copied, but length of my girder is different here, right? So in that case, what I do is this is where it has to change really, right? So I just drag it from here to here, and I mid section, right? So I'm just dragging it from here to here. Or you see that there is some issue as I just copied it. I should have assigned it. So or there is problem with my definition of my AutoCAD, that means. And what I do is I'll just move it from here to here because that line doesn't change. I don't need to drag it. Now it is adjusted. The lengths are adjusted. You get that? No? Clear? So this is called AutoCAD references. So let that be your box girder. What you will do is you will create a cross section with that point in area command for your box girder from your AutoCAD drawing, which you don't need to really care about.
ये जो प्लान में टेबलिंग दी है इसकी जरूरत है क्या? प्लान में टेबलिंग दी हुई है कि जो कमांड जो हम जो प्रॉपर्टी दे रहे हैं वो तो स्ट्रेट लाइन में दे रहे हैं केवल.
Good question. Very nice question. Now let me tell you. So this you see these things. These are AutoCAD references. This has got nothing to do with your structural elements. This is not your finite element. Your finite element is this. Your finite element is this yellow in color. You need to really, identify the difference between these two. AutoCAD में यहाँ पे एक अच्छा, I make a nice sketch using AutoCAD over here. But whenever I export it, it is no more exported. Finite elements नहीं है सर वो. आपके ये जो दिख रहा है, ये जो टेपरिंग जो दिख रहा है, वो बस AutoCAD का रेफरेंस है. मेरे रेफरेंस के लिए ये अगर नहीं आता यहाँ पे तो फिर भी मेरे को चलता. बस मेरे को वो आइडेंटिफाई नहीं होता कि मेरा कहाँ से कहाँ पे वो टेपर्ड है, ताकि मैं उसको टेपर्ड वो वाला क्रॉस सेक्शन डिफाइन कर पाऊँ. इसके लिए मैंने रेफरेंस के लिए. हाँ,
उसको लेके आने में जरूरत है कि कहाँ तक मुझे टेपरिंग करनी है.
एग्जैक्टली. मतलब मैं बोलूंगा कि जो मॉडल ऑलरेडी अपना कॉन्क्रीट डायमेंशन का जो मॉडल फाइल जो बना है उसमें से कुछ चेंज ही ना करो. वो जैसा है वैसा लाएंगे ताकि अपने को ज्यादा इंफॉर्मेशन मिलता है यहाँ पे क्या है, कहाँ तक कैसे कैसे जाना है. होता क्या है उसमें डायमेंशन रहते हैं. तो मोमेंट यू गॉट डायमेंशन वो स्विच ऑफ करो, डिलीट वगैरह करो वगैरह, थोड़ा बहुत मॉडल फाइल साफ हो गया, देन यू कैन स्टार्ट वर्किंग. दिस इज द आइडिया. So we will do this. So I'm just showing you, okay, different ways. Next way is axis based, जो आपने already देखा है. I don't now get into axis based. So you all three of you at least know what axis based is. Let's not spend our time here.
इसमें जो पेपर सेक्शन है, अगर मेरे को उसमें बीच में एक एलिमेंट चाहिए, एक नोट चाहिए, तो जो आई और जे सेक्शन है, जे बीच में आ गया, बीच में उसका जो क्रॉस सेक्शन होगा वो ऐसे होगा. फिर वापस जो नेक्स्ट एलिमेंट है वो वापस छोटे से बड़ा होगा. उसको ग्रुपिंग करने का कुछ वो है क्या? जैसे मिडास में करते हैं लोग ग्रुप टाइप कंस्ट्रक्शन.
Can you please repeat the question? So I just would want to know.
कि मान लो कि ये हमारा टेपर्ड सेक्शन है. दिस इज 2 मीटर लेंथ का है. ठीक है. यहाँ पे आपने कुछ विड्थ दे दिया, यहाँ पे कुछ विड्थ दे दिया, बट समहाउ मुझे एलिमेंट का एक नोड यहाँ भी चाहिए. ठीक है. तो मैंने डिवाइड कर दिया यहाँ पे. तो ये नोड ऐसा तो नहीं बना लेगा, ऐसे क्रॉस सेक्शन ऐसे तो नहीं बना.
नहीं.
व्हाट वी डू इन माइडस कि अगर आप टैपर्ड सेक्शन के बीच में एक नोड डालते हो तो आपको बाय डिफॉल्ट ही ऐसा रहेगा.
अच्छा.
इसका आई एंड पे ये प्रॉपर्टी, जे एंड पे छोटा, आई एंड पे बड़ा, जे एंड पे छोटा. अगर आप चाहते हो ये पूरा एक सिंगल की तरह करे तो आपको इन दोनों का एक ग्रुप बनाना पड़ता है.
You don't have to do a group like that. So I'll just export it and show you right away. तो क्या होता है कि I'll just highlight both the things. So what happens is that once you have got a tapered section, okay. So in this case, this tapered section, if you carefully observe, it starts from here and it ends here. आपको बीच में भी एक already वो बना दिया है. But as a user, you would want to go for more number of such station points. Rather, आपको वहाँ पे result चाहिए. What you can simply do is आप यहाँ पे जाओ, यहाँ पे एक point बोलो, ठीक है. Give it a good number. Number is 1 over here, and let's say आपको इधर mid point पे चाहिए. नोट डाल दिया मैंने. मैं बोलूंगा मेरे को और एक चाहिए यहाँ पे, और एक चाहिए. लेट मी सी व्हाट हैपेंस. फिर आपको 3 जगह पे मिलेगा. जहाँ पे आपका नोड है वहां पे आपको वो स्टेशन पॉइंट आपका बन जाएगा. फ्रॉम देयर यू कैन एक्सट्रैक्ट योर रिजल्ट्स. क्लियर? So let's go back. Let me just delete it. I say Control A and delete everything. And I go back to my simple system wherein I have got L enter and it asks me to specify origin 0,0 and 10 meters is my favorite beam element length. Okay. So I go back to line and I go to general. I can assign group number from here, which is very important. Let's say I give it group number 10. It is very important from your construction point of view, construction stages point of view. And element type is as cross section and I give it end section at start and end. And I just say that pick lines or curves and I just select it like this. And here is the conceptual view, something like this. Yeah. Now, My next task is to assign supports to this, right? Otherwise, this is an unstable system. So support is a point element, right? So you need to go to this point option here at the top. Okay. Left top corner is point. I click on that and comes the second tab, which is support conditions. Okay. And you can define global or local supports. So I'll go for local support PX, PY, PZ. If I restrain, it is going to be a pin. And I'll also go for MX, torsional restraint देता हूँ उसको, ठीक है? And I just click on this, okay? And what I further do is I release PX, okay? I also release MX and I assign over here at the other end, and that is something like this now, okay? Clear? I just export it. I export it. I say, okay. As a result, in SSD, I'll get a beam element like this. Okay, cross section आपको दिख रहा है. So this is where from my the line element really started. Okay, it is modeled over here. Okay, it passes from my origin. Okay, that's why it is like this. But we don't want our supports here. We would want it to eccentrically supported here using other bearings are located over there. So what you can do is you can put a rigid link in between and take this support down. So let me do it for you. I don't remember the depth of my girder. So this was this, and I say M enter and 1.45 meters. Okay. So this is the depth of my girder, which you can go and see in the conceptual view. So it is right at the bottom of my girder, right? Now what I do is I go to the wireframe view and I go to this something called point constraint. You see this? It is a rigid link. Okay. I click on that. So it is rigid. That means you need to select all of them, all constraints. Assign it a group number 0 is also okay. I click on this top node and go up to the node above. And also I go from this node at bottom to node top. So in this case, 2 is considered as a master element and 2 is considered as a master node and 1 is considered as a slave node. But Sofistik recommends Sofistik says that there is an algorithm in the backend in which automatically it understands which should be the master node and slave node, but it is good to follow practice that 1 is a slave node and 2 is a master node. Okay, to avoid in the when there are complex models at times that also runs into problems. That's why I'm just stating that. Now, so it is your simply supported beam. Okay. Yeah, yeah.
मान लो ये बीम गलती से मैंने 3-4 बार इंटर कर दिया हो कर लिया हो. How can I come to know कि इसमें एक सिंगल एलिमेंट ही है? यदि ओवरलैप करके बहुत सारे तो नहीं हो.
मैं क्या करता हूँ अभी इसमें CO एंटर करता हूँ और इधर इसको 1 मीटर पे लेके आता हूँ. अब मैं क्या करता हूँ इसको 1 मीटर पे. आई एम वेरी श्योर नाउ दैट मेरे पास 2 एलिमेंट. अब मैं उसको एक्सपोर्ट करता हूँ. यहाँ पे वार्निंग देगा देयर आर 2 ओवरलैपिंग स्ट्रक्चरल लाइंस. And it also further says that only first line will be considered in order to suppress. So वो दूसरा जो line है वो deactivate करता है, delete करता है इसको. Or what you can do is you don't like warnings, so go to zoom to. So it just selects that particular thing. Okay, जहाँ पे भी आपको overlap है, click करो, delete करो. अब अगर आप उसको export करेंगे तो you will not find such an warning because I already deleted it.
So if plus में there is no way to go. We have to export and see this one.
Yes, so I have this noted down this point और इसको हम अभी incorporate कर रहे हैं कि बिना export का एक जहाँ पे ये हो रहा है वो बताना चाहिए, ऐसा भी है. So now you have got a beam element which is supported like this eccentrically. Fine. Eccentrically modeled, eccentrically supported. Clear? Now I'm happy with this about the geometry part. Now I need to go to the third tab, which is loads. Under loads, there are load cases and actions. What happens is, do we have this? What happens is, you have got different load cases. Okay, LC2, LC3, LC4. In this case, LC2 is, let's say, SIDL. LC3 is, let's say, SIDL, but for varying board. It has got different factors, right? And LC4 we don't have it. So instead, what we do is we go for our combinations, okay, wherein our combinations will be, LC1 into factor 1.5 plus LC2 into factor 1.35, 1.7, whatever your factors are. But if you go to your course, okay, so this is for us. But if you go to course, in course, if you look at it is defined as per your actions. For example, it says dead weights or variable loads, or it says that SIDLs. So it will speak, based on those actions, okay, types, winds. So your load cases under wind load or seismic load can be in X, Y, and Z direction. But your factors, which are defined in the IRC, that table, are as per your actions. So your actions will be governing your load factors. And there can be multiple load cases in those actions containing the same load factor to it. That's why there comes a need to define something called actions, or in MIDAS it is called load types. So that is very clear to you now. When I say load types, it is clear why is it required, right? So in order to perform combinations, you need to work with the action. This is the idea. Or the user can also work with like this, the each load case into the factor and all. Okay, that's why we need to specify each of the load case to an action. Okay, so what we do is here, okay, in the load case manager, okay, there are two tabs. One is the tab for actions. So there is first action already automatically defined, which is G_1, which description is for dead weights. Okay, superpositions we currently keep away from our discussion, at least for our this beam type model, simple model. I say that I want to create a new action, which is G_2, okay, which is also under partition called permanent. Okay, I can create furthermore action, okay, and which would be, let's say, pre-stressing, which is P, and I say okay. I create furthermore action, and which might be pinned or something, or I just remain with what actions I have, or E for seismic loading. So these are predefined action symbols, okay, which comes as it is from European standard. So if you open Eurocode EC2, you will find exactly this terminology, and this has been developed over there, okay, for their requirements. That's why it is this G_1, G_2, G_3, so on and so forth. So we just leave with it for now. For us, what is more important is load cases, okay? And I say new load case, and the title is self-weight, okay? Self-weight, and action I am assigning to it is G_1, and factor for self-weight is 1. I create another load case, I say new, and I give it a title SIDL, or an external load, I'll say EL, external load, and I assign it to action Q, okay? And factor for self-weight is 0 in that case, and I just remain with it, and I simply say okay. So I got only two load cases with factor for dead weight 1 for self-weight case, and factor for dead weight 0 for external load case, and I say okay. So here under loads, you need to assign it here, right? So let's say that you would want to assign point element. So what I can do is I can go to free loads, point elements, and I can give it some name, or need not give any name. I simply select load case 2, and value is 10 kilonewton, and type is in the downward direction, the gravity direction, and I select a midpoint from here like this, and it is assigned. Okay. So we will get into depths of this. Okay, what free loads are, what element loads are, why point load under element load, why point load under free load. We will discuss all this. But there is only one load case to be assigned, self-weight case. It should automatically considered based on the self-weight, unit weight, and the cross-section area and the volume it calculates on its own. So if I export this, so in Sophie Plus, this graphical user interface doesn't have capability to perform further analysis and all. Okay. it needs to export this model to our SSD. So I export the model to SSD, and you see that here the model is, and you need to go to next task, which is called linear analysis. I double click on that, and it asks me to select load cases manually or select all the load cases. I select all of them, and I simply say OK. It has performed the analysis, and under system visualization, you can see the behavior of the structure. Okay. Now what I do is I just go back to my Sofistik Plus and I say that I'm not happy with this 10 kilonewton. I double click on that and I say that I would want to go for minus 10. I would want to go for minus 10. And I apply. So now it is going in the upward direction. Okay. Easier for us to view our results, nothing else. And I export it again, SSD, and I perform linear analysis. I go to home, I go to WinGraph, and here I can see in the loads, input loads, all loads, I can very clearly see here under load cases, self weight is generated. So I did not ever assign this self weight, right? So the unit is here kilonewton per meter. Are you all getting what I'm saying? So did we ever assign 15 kilonewton per meter? No, I did not do that, but it calculated on its own. Okay. And here in the output, it is showing me that your the self weight is 15.09 kilonewton per meter. Now, why I'm stating this is because whenever if you are going for any checking and all, okay, I want to verify what my cross section area is, then I can simply go have a look at this number divided by my unit weight and come back to my cross section area. Then I get that assurance that जो मैंने मॉडल किया है मेरे definitions जो है वो सही है. You get further. If I go to external load, then that was this load, upward 10 kilonewton load. This is how you look at your loads. So if you are checking your models, you don't need to go to Sofistik Plus again every time. अगर किसी यूजर का मॉडल आपके पास आता है, you don't need to go to open his model, go to Sofistik Plus, check करना, क्योंकि वो जो गलती कर रहा है वही गलती अपने से भी हो सकती है. So you need to simply go to this post processing mode, wherein you can just verify what has been assigned and whether it is correct or not. Go to results, beam elements, forces, and bending moment My. This is your bending moment My for load case number 2. And for load case number here is the bending moment. You can have a look at your deflection results going to the nodes, nodal displacements, and global Z here. This is downward displacement and this is upward displacement. So one more point I would like to highlight is that people say that it is, suppose if you've got a big structure, okay, and you have got only small screen to have a look at your results. Then in that case, how to really have a look at the results. So in that case, what you can do is, for example, you would want to get into the depths of the things, okay? You are also want to see over here the beam element numbers on top of this. So I say on new layer, and in that I would bring in all my beam element numbers. So beam elements, number of the element. You see that this was the 10,001 to 10,000, those things. And let me just go back. There, and I want to show here My. So I'm showing you now for each of the beam elements what is my My value. Okay. So any data that you have in your model file that can be visualized through this particular WinGraph thing, everything. So right from start to end. Now the problem is that you cannot really have a look at the beam number over here. Since you are looking at result here at two things, there should be a beam here. No, there is no beam. 10,004 and 10,005. But I'll just go into D%. There is no beam element over here. Okay, fine. If you want to have a look at, let's say, result for only beam element number 10,003, in that case, what you can do is you can go here at the top. There is an option to isolate that thing from, from here. You can take a box and you would want to isolate only this part. You isolated it. Okay. And now you are having a look at only and only the beam element number. If you would want to see what cross section has been assigned, then you can simply go back and you say that cross section. What is the cross section? It will show you what cross section has been assigned. So any information in the pre-processing mode, okay, will be brought to this particular interface, which is called WinGraph, which is very important. Clear? Now, what we do is, you did not do it right, these things. You would want to do it quickly.
Yeah, yeah.
सारा ये अब तक जो किया उतना करेंगे फिर चलो let's do that. I'll start with you. I'll just go back to my first screen. I'll control N. I'll delete everything. So your defined materials or defined materials भी नहीं define किया आपने. Materials किया ना, cross sections किया आपने. No. So should I email that model file with you all? So I'll send it to sir and sir may forward it to everyone.
लंच क्या लोगे? नमक, ये सब्जी टाइप्स चलेगा? थाली टाइप?
कुछ नहीं पता नहीं अब तक तो मतलब कुछ ये नहीं. So I'm just planning to go to one more office actually.
अच्छा, आज कब?
Lunch break.
लंच, फिर you'll come back, हाँ?
Yeah, come back. Lunch, good to have lunch here, I'll say.
Yeah.
But anything that is, not too heavy.
Maybe.
Yeah.
ये सब chess. बोलो, एक लंच ऑर्डर करना है सर का जो है. ये क्या ऑप्शंस है, कुछ है क्या? मेन्यू कार्ड है क्या कुछ? क्या ऑप्शंस है? वेज थाली, कोई लाइट ऑप्शन है कुछ? एक बार पूछ के बताओ थोड़ा. ओके, भेज दिया आपने?
हाँ भेजा email नहीं है क्या?
ठीक, ठीक है. लाइट ऑप्शन मंगाती हो ना? क्या साउथ इंडियन चलेगा?
हाँ चला डोसा भी चलेगा कोई प्रॉब्लम.
अच्छा, डोसा. हेलो नूर, डोसा मिल जाएगा? ठीक है, ठीक है, एक प्लेट एक डोसा कर. ठीक है, भेज दिया आपने?
हाँ सर भेज. So let's model the cross section and you should model that T gutter cross section. So what you do is open this AutoCAD file in the model space. Here you first go to this sheet DIMF. Have a look at what kind of geometry it is.
फाइल ओपन करें या उसको
अच्छा, आप उसको ऑटोकैड है आपके पास? आपके पास सॉफ्टवेयर क्या है आपके पास?
मिडास करेंगे।
मिडास खोलो ना, मिडास कैड में।
बस एक मिनट
सर
एक आखिरी प्रॉब्लम इन्होंने दिया है ट्रेनिंग वाले को बताना
आपका हो गया सर वो?
नहीं
चालू
नहीं
नहीं, चलो किसे किसे
ऐसे ही
काम करना है आपको। ये है आपको। So please open this file. So you got which CAD?
नहीं हो गया ऑटोकैड।
नहीं, आप कौन सा CAD यूज करते हैं?
मिडास करेंगे।
मिडास CAD, मतलब उनका
मिडास
भी
का भी क्या है?
CAD है क्या उनका? गुड यार।
मिडास है।
Step एक। हाँ?
ये एक प्रॉब्लम आ रही है
अच्छा, क्या बोल रही है? तो तीनों को भी आपने इंस्टॉल किया, डाउनलोड किया?
क्लियर
क्या हो रहा है? आपके दो बार ऑलरेडी ओपन है।
मैंने वहां से एक्सपोर्ट किया है, तो ये यही आपके रुका हुआ है।
क्या सिस्टम के
अच्छा यहाँ
स्टेप बाय स्टेप
बिगेस्ट है
मैंने आपको वो जो ऑर्डर करता है फाइल दिया
और दूसरी
क्या? दिया। आपके पास क्या ऑर्डर कार्ड है?
हार्डवेयर
ओपन दूसरी मॉडल ऑर्डर कार्ड है। ये भी जो तरीका है ना, सबसे प्लस इसका भी
ये तो मतलब
इसको डबल में करोगे आपको सभी प्लस में मिल जाएगा। वो भी कर सकते हैं अगर सेपरेटली ओपन किया तो आप जो भी सारा ऑटो कैड इसको ऑटो कैड करके भी यूज कर सकते हैं सॉफ्टवेयर। इसमें ओपन एंड यूजर के ओपन कंफ्यूजन बाकी Did you open this file, everyone? So did you see what geometry is? So this is a file that I received from one of the design offices. And what I did is I went to the model space and यहाँ पे हमारे यूज के लिए छोटा ऐसा एक बना के रखा है मॉडल मैंने। यहाँ पे ऊपर अगर जूम आउट करोगे तो यहाँ पे आपको क्रॉस सेक्शन भी मिल जाएंगे। इन क्रॉस सेक्शंस का इस्तेमाल करेंगे।
क्रॉस सेक्शन का रीजन बना के रखना है हमेशा जब भी इंपोर्ट करना है।
हाँ नहीं, एनक्लोज लाइन बनाना, पॉली लाइन बनाना। Polyline.
या line connected.
Line भी connected रहेगा तो फिर कोई problem नहीं. So it should be only enclosed. That's the. Please go to the cross sections. Right click. Say new solid section. Say reinforced concrete. And give it a name mid section. Section 1. Material I keep its grade as M40 grade concrete. Go to the next tab, that is stages.
Section name cross section करेंगे.
Give it stages, say new, stage number 10. Update its name to, let's say, girder activation.
Possible.
Yes. Stages.
स्टेज नंबर कुछ भी रैंडम रखें. 1 2 3 ऐसा भी रख सकते हैं. 10
कुछ भी रख सकते
कुछ मतलब नहीं.
बस उसका सीक्वेंस आपको सही से देना.
Increasing order.
वो भी इसलिए कि मतलब देखो आपने अगर 10 मॉडल किया और 20 किया तो आपको कल आप चाहते हो कि बीच में एक स्टेज डालना है तो 15 डाल सकते हो.
सर इसमें आने नहीं. Better activation.
Then these things. So I'll say that you create a new stage for your flange activation and I give it number 100. 100 कहाँ से है तो एक रैंडम नंबर है 10 के आगे वाला. 40 दूं 50 दूं 60 दूं लेकिन 100 कैसे कि थोड़ा मेरे को दिमाग में रहता है कि मेरा कंपोजिट एक्शन 100 पे आता है हर बार आता है. ये इसमें आता है ऐसा नहीं केबल स्टे भी करूँ उसमें भी ऐसे सिस्टम में 100 ही रखूँ. जैसे मेरे जो ग्रुप नंबर्स है कॉर्ड एलिमेंट्स के मैं कभी भी उसको 11 नंबर देता हूँ पिछले 10 साल से. तो टीम एलिमेंट है तो वो थोड़ा ऊपर नीचे होता है लेकिन कॉर्ड एलिमेंट अगर रहेगा तो उसको 11 नंबर ही देता हूँ. मैं तो उसके मल्टीपल्स में देता हूँ 11 22 33. लोड कॉम्बिनेशन से उसको भी अगर नंबर देना है तो मेरे को पता है यूएलएस कॉम्बिनेशन देना है तो उसको यही देना है. अगर स्ट्रेस रिजल्ट है तो उसको भी आप इसमें नंबर डिफाइन करना पड़ता है तो उसके जो स्टोरेज लोड के जगह 9000 ही से कुछ देता हूँ. वी विल सी दिस ऑल ताकि एवरी यूजर इन द लेटर स्टेज ऑल्सो मतलब आपको भी मतलब आपके ऑफिस में सपोज मैंने फाइल बनाई है तो वो सर के पास जाती है. सर को भी एकदम क्लैरिटी 9000 में मतलब वो ये नो कंफ्यूजन. इसको मैं नाम चेंज करता हूँ. फ्लांज एक्टिवेशन और कंपोजिट एक्शन व्हाटएवर यू कॉल इट. So you enter into altogether a new environment and it's called cross-section editor. Here now you would need a reference, right? You need to go to your AutoCAD file, select your midsection, And now you would want to copy it from this environment to the other environment, right? So instead of doing only Control C, if you do Control Shift C, it will ask you for the base point for selection and base point for insertion, which is a controlled approach. So I go with Control Shift C. It asks me to specify base point now. So I select here, click on this, okay, at the top of my girder as this. It picks up that point if your all snaps are on. Okay. So I click on here, okay, at girder top. I go back and say Control V, and it asks me to specify insertion point. I say 0, 0, enter.
जीरो कॉमा जीरो से ऐसा कुछ मतलब नहीं है. It can be anything ना.
It can be anything, but cannot be anything. सपोज आपने अगर ये इसको पेस्ट किया इधर,
हाँ.
तो आपका लाइन एलिमेंट जो मॉडल होगा वो इधर ही ओरिजिन पे मॉडल होगा.
Okay. इसका जीरो कॉमा जीरो इज द टॉप ऑफ या फिर
Your line
ऑफ
element.
लाइन एलिमेंट.
इट इज लाइन एलिमेंट का लोकेशन. अगर सपोज आपने इसको ये जो ओरिजिन ऊपर मतलब इसको नीचे अगर आपने किया था तो आपका लाइन एलिमेंट नीचे होगा मॉडल के सेंटर के लिए. अभी टॉप रेफरेंस है आपका क्रॉस सेक्शन का जो टॉप है अभी वो रेफरेंस है. वो केस में आपका क्रॉस सेक्शन का बॉटम रेफरेंस है. So now you need to use mirror command. Just mirror it. So put it, mirror it. Yes. Yes मैम आपका हो गया. मिरर कर लिया आपने. सर का होगा सर. मिरर हो गया सर आपका.
हाँ. फ्रॉम बेस कंट्रोल शिफ्ट सी. कंट्रोल शिफ्ट सी. इस बार वन में इसका कंप्लीट लिख दीजिए. सब कुछ प्लस हो जाएगा. क्या कंट्रोल में कीजिए. कुछ है जीवन में से अभी हम इंटरेस्ट अच्छे.
अच्छा ये ऑफिस के अंदर पहनने के लिए अलग चप्पल आप यूज करते हैं क्या?
फैन खाली करने दिक्कत होती है.
मैंने आपके ऑफिस में आने के लिए नए जूते खरीदे बाहर निकलने के.
ऑफिस के लिए नहीं होते. लॉस
मैं उसको भी बुला रहा हूँ मेरे जूते नए हैं. बोले बाहर निकल मैं बोला अच्छा मैं मंदिर जा रहा हूँ मैं क्या बता.
एमआई फिर एमआई
So I think we are all done with up to this. So what we now next do is we would want to create a boundary. This will give structural sense to this AutoCAD reference lines. I repeat that these are just AutoCAD reference lines, nothing else. It has got nothing to do with your structural things, finite elements, and nothing. So you go to this option boundary. So we say that it creates a boundary for the cross sections. You can select here appropriate material from this drop down menu. I select M40 grade concrete. Here I go to construction stages and select this construction stage number 10, appropriate one. Further, there is option for this parametric reinforcement. I don't touch it at all. Okay. Perimetric reinforcement basically. And I simply go.
ये आया अरे सिर्फ मटेरियल आ
हाँ क्या? रहने दो, कोई बात नहीं।
आपको कौन सा है 24 है
25 है। नहीं, थोड़ा 25 में थोड़ा ये जस्ट 1 month ऑलरेडी। So थोड़ा वो अभी उसका 25.12 जब आएगा तब वो सेटल हो जाएगा। तो I go back to point in area here. और also मेरा ये जो नया जो कंप्यूटर है इसकी वजह से भी कुछ कुछ चीजें हो रही है। So point in area, this option and I just click inside this. अभी आपको escape नहीं करना है, आपको next वाला भी करना है ना point in area. Don't
इसके
escape.
पहले हो रहा था ये हो रहा है
हाँ?
जब वो रेक्टेंगुलर सेक्शन बना के ट्राई कर रहे थे तब हो रहा था
क्या हो रहा था?
कि मतलब पॉइंट को सिलेक्ट किया तो वो एरिया सिलेक्ट किया
अभी नहीं हो रहा है।
नहीं आता वो ऑप्शन ही बाउंड्री सिलेक्ट करने
नहीं हो रहा है। ठीक है, मैं आता हूँ। What we next do is we want to go for this. Let's say that we want to change the material from M40 grade concrete to M45 grade with zero self weight. अगर आपने if at all you are modded, okay, no problem. Otherwise, वैसे ही रखो, कोई problem नहीं. And I select this construction stage as 100. And my point in area was already selected. You need to simply go and click inside this. That's done. Just go and close this down or simply do escape. बस एक दो बार escape कर दो ताकि you are just outside everything. Yeah. Escape it. Outside all commands.
इसको भी क्लोज कर लो
Yeah, escape बस सही. You're here. आपने अब तक उसको एनालाइज नहीं किया, उसको आपने कैलकुलेट नहीं किया क्रॉस सेक्शन प्रॉपर्टीज. So now what you do is, so here you see there is green, but below green there is red. Okay, so that boundary is generated. So there is something called draw order. So you can do right click, draw order and bring to front. Then that you know that that issue will be resolved. Draw order, bring to front. Okay.
इसको फ्रंट कर देंगे
आपको अगर वो रेड देखना है ना तब आप ये ड्रॉ ऑर्डर को यूज करो. और व्हाट यू कैन डू इज you can simply go here at top right corner and give it a run. तो वो रेड ऊपर आ जाएगा, बाउंड्री ऊपर आ जाएगा. So at the same time here in the bottom command space here you will be able to see the numbers associated with this your
ये करने के बाद में इधर काफी सारी चीजें मैसेज आ
क्या हो गया, क्या बोलते हैं.
and the reference material has no property using project to sustain
Those right now.
see it's it is
This right here and delete.
oh so what do you need to do it's easier
उसका और इसका कुछ ये नहीं, just
था बोलते हैं हम लोग पे ये पॉइंट्स भी दिखा रहा हूँ ये आर स्ट्रेस पॉइंट्स
स्ट्रेस पॉइंट्स आप इसको डिलीट भी कर सकते
ऐड भी कर सकते हैं
हैं, यहाँ पे भी जहाँ भी चाहिए वहाँ पे ऐड कर सकते हैं। और अगर आपको गर्डर टॉप, स्लैब टॉप, गर्डर टॉप और गर्डर बॉटम में इंटरेस्ट है, उसका नाम भी देता है जीबी एसटी जीटी। So what I now do further is I keep my, so just for your information, I can delete these stress points or define my stress points, let's say at slab top, gutter bottom, my points of interest anywhere in the cross sections. You don't do it now. So I hope you could all analyze this cross section as well, right? And if you press F2, you should get these numbers. Okay. So the moment you get these stress points defined and you get this shear center here and centroid over here, that means your cross section is assigned. So I just close this down because your first cross section is defined. Clear? Now what we next do is we want to create end section, right? End section we can create by simply cloning this. So I do right click and I do clone. It asks me for next ID. Say okay, I double click on this cross section properties and I give it a name end section, END. One, everything else remains the same, nothing changes. बस उसका मैंने नाम बदल दिया. Same thing I do, I go and bring in this reference into picture from here to here, Control V. I do MI enter here and I just go with this. This is now my next new reference wherein I need to simply drag my vertices to get it on top of this. So how good it has rained this year in Delhi?
How good is
It has rained in Delhi, good or bad or क्या बारिश? अच्छी बारिश हो अच्छी बारिश. अच्छा तो हमारे ये साल अच्छा जाने वाला है सा.
अच्छा तो बुरा तो पता नहीं
तो बारिश के टास्क में इसकी बात करें सर.
ये सब ऐसे करना और डायरेक्ट हो गया
ये ऑटोकैड का लाइन, ये ऑटोकैड का लाइन में इसलिए ला रहा हूँ कि मेरे को कुछ तो रेफरेंस चाहिए ना कैसा मेरे को ज्योमेट्री बनाना है. ठीक है, इसका और मैनेड एलिमेंट से कोई संबंध नहीं. अपने क्या करता हूँ ये बाउंड्री में जाता हूँ इसको. ठीक, पॉइंट एरिया के हिसाब से इधर वो बना मैपिंग रखे. अब वो बन गया, अब यहाँ पे आपको दिख रहा है वर्टेक्स रेड कलर. अब वो उसको फाइनल एलिमेंट्स का संबंध नहीं. Says that material number is 1 is used in different construction stages, this can cause problems. Up to what is it mean? Spot protein. Select करो इसको, हम एंटर करो, ठीक, क्लिक करो, सबसे पहले आपको स्नैप का जो ऑप्शन है वो सब तरह की स्पीड्स अगर यूज करेंगे तो आपको सूट आएगा पॉइंट्स है सब। नाउ योर क्रॉस सेक्शन इज मॉडल, ये हो गया आपका मॉडल। आपको अभी मॉडल करना है 10 सेक्शन, वापस 0 से स्टार्ट नहीं करूंगा, इसको क्लोज करूंगा।
सर नॉर्मली क्या होता है ये जो ये जो ट्रेनिंग सेक्शन होता है हम उसमें जो बुकलेट देते हैं स्टेप रहती है कि ये स्टेप्स ये 1 2 3 4 तो उसमें कुछ है आपको स्टेप्स में है कि तो वो फंसे कि सब वो कर वो क्राइटेरिया है मीटर वीडियो सो कुछ करते हैं वो शायद क्राइटेरिया तो पॉलिटिकल को रेफरेंस सो मैं बेसिकली ये फॉलो करते हैं ये मैं ऐसे तो पहले वाले उसमें यही स्टैंडर्ड मेथड है। और इसके अलावा इसका रिकॉर्डिंग भी सेशन है, वीडियो भी है, ये सारा रिकॉर्डिंग भी है। कंट्रोल से ये तो पूरा पैरेलल एलिमेंट से है। हाँ देखा देखा कॉर्नर की मतलब मेरे तुम भी ओके आपको देखो मैंने क्या बोला ऑटो डिफाइन जो भी स्ट्रेस पॉइंट आ गया कि अगर मैं इधर डबल क्लिक किया तो ये क्या बोलता है, दिस इज माय स्ट्रेस पॉइंट, इसका नाम ये है, ठीक है, इसमें मटेरियल ये है, सो ऑन एंड सो फोर्थ। अब मैं क्या करता हूँ तो कि मेरे को ये जो है इसके अलावा इधर भी चाहिए, गर्डर टॉप नहीं तो गर्डर बॉटम, तो यहाँ पे ऑप्शन आता है स्ट्रेस पॉइंट और मैं उसको नाम देता हूँ जीबी विच स्टैंड्स फॉर माय गर्डर बॉटम, ठीक है। माय मटेरियल इज दिस एंड ऑल दैट्स फाइन। और मैं बोलता हूँ कि गर्डर का बॉटम मेरा ये है, मैं एजेस पे नहीं देखना चाहता, मैं बस राइट एट द सेंटर देखना चाहता हूँ। बस मैंने एक नया स्ट्रेस पॉइंट डिफाइन किया जहाँ पे मेरे को विन ग्राफ में मेरे को आउटपुट दिखेगा स्ट्रेसेस का। अगर मैं चाहता हूँ और एक मैं डिफाइन करूँ यहाँ पे, मैं कर सकता हूँ, यहाँ पे करना है कर सकता हूँ। मेरे को ये वाला डिलीट करना है, इसका मेरे को लगता है कोई फायदा नहीं, तो मैं इसको डिलीट भी कर सकता हूँ। वाई एडिशनल इन्फॉर्मेशन, वी डोंट वांट लॉट ऑफ इन्फॉर्मेशन, मैं इसको भी हटा देता हूँ, सो ऑन एंड सो फोर्थ पॉसिबल है, ठीक है। नाउ व्हाट आई डू इज आई नीड टू इंक्रीज माय वेब थिकनेस फ्रॉम दिस टू एंड सेक्शन का थिकनेस। तो मैं ये जो वर्टेक्स है इसको पकड़ता हूँ और राइट में से खींचता हूँ, परपेंडिकुलरली हो जाके पकड़ रहा है, दैट मींस इट इज करेक्ट, आई एम ओके विद इट। ये वर्टेक्स है, इसको यहाँ से उठाता हूँ, यहाँ पे लेके जाता हूँ, ये उठाता हूँ यहाँ पे, इसको इधर लेके आता हूँ, ये उठाता हूँ, इसको यहाँ पे लेके आता हूँ। यू सी दैट एंड आई गिव इट अ रन नाउ। अच्छा इसको ऊपर लेके जाओ, मैं इसको ऊपर लेके जाओ, सॉरी परपेंडिकुलर ना लेके जाके मैं इसको। अब बात आप एक समझ लो, ये जो नीचे वाला जो ग्रीन लाइन जो था वो ग्रीन लाइन वहां पे ही है, उसका कुछ मतलब ही नहीं, वो तो बस रेफरेंस है। उसको मैं डिलीट भी किया तो फिर कोई प्रॉब्लम नहीं, रहने दो ना, लेकिन क्यों डिलीट करना है।
ये वाला पॉइंट यहाँ जाएगा।
हाँ सही, नो यू नीड टू सिलेक्ट या क्लिक ऑन दैट। हाँ सही, परफेक्ट।
Just ये जो overlay ये परपेंडिकुलर जाएगा।
अभी तो
वो तो एक ही बार है।
सर वो सर के साथ वो ईमेल फॉरवर्ड।
हाँ सर, तो अभी तो आप वही तो अभी तो आपको ही फॉलो कर रहे हैं तो
दो बार वो कर दो।
अच्छा, आपको वो फॉलो करने से मैं कहता हूँ
एक काम कर पूरा सिलेक्ट कर और सबसे कौन
टीम पे शाम
मैंने वाला नहीं बना
क्या?
मेरे को मेरे सपने बनाए हो
हाँ
उसी को प्रॉब्लम किया
हाँ, रोस्टेड
Okay, so let's just move ahead. हो गया, आपने इसको किया तो you need to give it a run. नया जो क्रॉस सेक्शन बन गया अभी आपको ये मॉडिफाई करके you should run it. एक बार रन हो गया, just close it down. Save. ठीक है, अब बात आती है कि definition of your beam elements, right? Line elements. So I create one simple small line L enter जो AutoCAD का लाइन में बनाना चाहूंगा 0,0 ओरिजिन रहेगा और 10 मीटर का लाइन है, ऐसे एक लाइन बना दो यहाँ. Now I go to structural elements, I go to line, I go to general, I can assign it a group. Let's say I give it a group number 10, beam oblique cable as per cross section. And mid section पकड़ता हूँ मैं and I should pick lines or curves and I just assign it a line. So please help out each other. Okay, follow. So let me know once you have drawn such a line. So you can simply go to the conceptual view and verify that you have assigned it a cross section.
ये एक्सिस का इशू आ गई.
अब वो शायद वो जो वहाँ का जो ऑर्डिनेट का रेफरेंस वो शायद वो इशू नहीं था. हाँ तभी फर्स्ट
एक मैसेज आ रहा है.
Okay, so it means that the distance between the two vertices that you are modeling is very short, very small somewhere. Or there is finite elements का एक requirement रहता है कि उसका जो angle जो रहता है between nodes and all 160 या कुछ तो cross नहीं होना चाहिए. That, but you can remain with that. Analysis ये आगे बढ़ रही बात या बात ही नहीं आगे बढ़. It's a warning, right? Not an error. दो नेक्स्ट टाइम थोड़ा अच्छे से करेंगे जो नेक्स्ट जो मॉडल रहेगा उसमें. So what we now next do is, so you know now how to assign cross section to your beam elements and how to model your beam element. Further what we do is we model a support which is your point element and I go with local px, py, pz and mx. Okay, so what I do is I just create a support over here, and I release my PX and MX and create another support over here. And
वो देख रहे हैं conceptual view.
conceptual views में मॉडल मत करो, मॉडलिंग कर रहे तो 2D वायर फ्रेम में
नहीं, follow it.
हाँ वो हॉलो नहीं है,
नहीं,
वो हॉलो का एक बार मॉडल करेंगे दूसरा, तब आपको समझेगा हॉलो कैसे दिखता है। फिर एक बाउस कटर बनाएंगे जिसमें वो हॉलो रहेगा, तो उसका अलग से दिखेगा आपको।
जूम के साथ क्या होगा, जूम ऑन
नहीं नहीं नहीं, बात नहीं है कि आप जैसे आपको ये सब चीजें करनी है, you should
अच्छा,
just
hollow
go
wire,
to your
okay.
2D wireframe, then only things will work. और they don't. कभी कभी ऐसा होता है कि आपको समझते नहीं आता मॉडल कहाँ पे, पेड़ में क्या करते हैं। You are all able to follow, right? Yes, you two. So, may I know your good names?
Krishna.
Krishna. Yours? Sarthak. Sarthak. Your full name, please.
Krishna Joshi.
Okay, Krishna. Yours?
Another PP. Another PP.
Peep.
PP. PAP, right?
Peep 3. Okay, yours, ma'am. Akhila, your full name, please. Okay. You're all able to follow?
Yeah.
No? थोड़ा सर कहीं थोड़ा सर your good name, sir, please. Okay. So what we can do for sir is
नहीं मैं लंच में जो है इसको देख करके मैं करूंगा, कल तक में मेरे ख्याल से उसमें हो जाएगा प्रोजेक्ट।
क्योंकि मैं ये नहीं चाहता कि हम ऐसा मॉडल करें और आप हमारे साथ नहीं हो तो
नहीं नहीं
सही
नहीं
नहीं
नहीं,
लगेगा।
आपके साथ ही आप कर देंगे, कल तक मैं पिक कर लूंगा, डोंट वरी, अभी आप कर देंगे, प्रॉब्लम।
ठीक है सर। So you have got a beam element now modeled. Everyone has modeled this. So we would now want to take these supports to, lower level. So I say select them and say M enter and 1.45. Right? So point constraint I'll assign. I'll keep its group as 0. And from this place to here, from this support to here. Okay, and I do escape. So all these objects you can select, copy, paste, move, all AutoCAD functions that you would want to do, right? What I now further do is,
It's 1.45 ML.
अगर आप स्टैड यूज करते रहे वेरी एफिशिएंटली, ये भी हो जाए। अब AutoCAD भी तो यूज करते रहेंगे,
नहीं बाकी स्टेप्स हैं जो अदर स्टडी कोई दिक्कत नहीं,
आपको थोड़ा हाथ में बैठे बाकी कुछ नहीं। लेकिन सर हम इसको सारा रिपीट करने वाले हैं अभी जो बनाने वाले ना, जो मॉडल एक्चुअल मॉडल, इसमें फिर से सारा फिर से रिपीट होगा।
ठीक है।
लेकिन
इसमें ऐसा भी कुछ है कि पॉइंट कंस्ट्रेंट हम ऊपर से नीचे भी कर सकते हैं।
कर सकते हैं, कोई प्रॉब्लम नहीं होगा। लेकिन अगर बहुत बड़ा मॉडल है वो केस में अगर ये फॉलो नहीं करते तो वो थोड़ा प्रॉब्लम देता है। फिर रेयर केसेस में देता है, वेरी रेयर, देन वी रिकमेंड कि नहीं वो यू शुड हैव मास्टर नोड एज 2 एंड स्लेव नोड एज 1।
उस दिन तो कह रहे थे कि यह मास्टर स्लेव जैसा ऐसा सॉफ्टवेयर स्मार्ट
है ना, मैं वही बोल रहा हूँ।
सो हम कहीं भी यू कैन क्लिक फर्स्ट,
यू कैन क्लिक फर्स्ट, नो प्रॉब्लम। बट ऐसा मैंने देखा कि 1% टाइम्स इट हैज हैपेंड। मतलब मेरे पास क्वेरी आता है कि बहुत बड़ा मॉडल पड़ा रहता है वगैरह, और उसमें वो फिर बोलता है अरे ये कनेक्शन का इशू आता है, तो वो टाइम पे फिर वो मास्टर स्लेव को फॉलो करना पड़ता है। तो इसलिए आई विल रिकमेंड कि सॉफ्टवेयर इज स्मार्ट इनफ टू आइडेंटिफाई दैट, बट आई विल रिकमेंड कि आप इफ योर मास्टर नोड इज गो फॉर 2, स्लेव नोड 1 पे। या कुछ दिन पहले मैं ये नहीं बोलता था, कुछ दिन पहले मैं भी वही बोलता था कि वो खुद से कर लेगा।
इसलिए बाउंड्री कंडीशन देते हैं ये, बजाज में इसमें सेम है, कुछ इसमें अलग है।
Same and boundary condition. See, we have got only 6 degrees of freedom for our nodes.
रिजिड और की आप मास्टर स्लेव वो सब तो सब
सब सेम, सब कुछ चेंज नहीं सर, ये तो सेम ही एक ही है। स्टैड लो माइडस लो से भाई, ये बस मतलब मॉडलिंग का थोड़ा फर्क है, और ये मेशिंग का इसमें थोड़ा फर्क है। इसमें बाद में मैश होता है, उसमें जितने नोड्स डिफाइन करोगे उतना मैश चाहिए आपको। ये फर्क है, बस यही एक फर्क है फंडामेंटल। बाकी क्या ऑटो कैड बेस्ड है, ऑटो कैड जैसे कॉपी पेस्ट कर सकते हैं, वहां पे आपको ट्रांसलेट करना पड़ेगा। अभी फॉर एग्जांपल मैं आपको बोलता हूँ, तो व्हाट आई डू इज आई एम वेरी हैप्पी विथ माय वन गर्डर दैट इज मॉडल, दैट्स इट। मैंने इसको कॉन्सेप्चुअल व्यू किया, ठीक है। इसको मैं कर दूँ CO एंटर, ठीक है, और मेरे पास बहुत सारे गर्डर्स है, तो मैं इसको एरे बनाऊंगा, ठीक है। मैं बोलूंगा मेरे 30 गर्डर्स इन लाइन एंड स्पेस्ड एट आई डोंट नो व्हाट द फ्लांज विड्थ एट द मोमेंट इज, but it is at I think 2.95 meters. I have modeled it now 30 times. So this is advantage because ये AutoCAD है। इसको मैं मूव कॉपी पेस्ट ये वो कर सकता हूँ। मैं एक स्प्रिंग एलिमेंट, हाँ ये स्प्रिंग एलिमेंट में मैंने एक मॉडल किया, तो मेरे को 1-1 मीटर पे देना है 1.5 मीटर। वो AutoCAD के अगर आपका वो है रेफरेंसेस, तो आप बहुत स्पीड में ये सारे काम कर सकते हैं। एक फाइल मॉडल कर दे विथ स्प्रिंग एलिमेंट्स, तो आपको वो फाइल को बस सारी फाइल को विथ स्प्रिंग एलिमेंट्स कॉपी करना है, पेस्ट करना है 4 जगह पे, टू क्रिएट 3 more your file elements. You get what I'm saying? So मतलब ease of modeling यही फर्क है। बाकी सारा उसका रिजिड लिंक कैसा काम करता है, सबका सबका सेम है। मास्टर स्लेव जो थ्योरी है वो तो सेम है, कोई फर्क नहीं। ठीक है, so I just do Control Z. Now what I need to do is I need to model loads, right? So I go to third tab, also very important. It follows workflow is such that it will follow top to bottom and left to right approach. मतलब ये भी अगर आप देखोगे कि तो पहले टॉप से लेके नीचे नीचे तक जाएंगे हम लोग। लेफ्ट टू राइट अप्रोच मीनिंग अगर मेरे को लाइन एलिमेंट अगर मॉडल करना था, तो पहले मैं जनरल टैब पे जाऊंगा, फिर इस पे जाऊंगा, फिर इस पे जाऊंगा, ऐसे ही जाएगा हर बार, ये यही सेम रहेगा, ठीक है। नाउ आई वांट टू गो फॉर माय लोड्स। लोड्स के लिए मेरे को लोड केस मैनेजर में जाऊंगा। एक्शंस मेरे, आपके इसमें क्या एक्शंस डिफाइंड है? जस्ट यू गॉट एक्शंस डिफाइंड राइट, G_1 एंड Q, दो है ना ऑलरेडी। स्ट्रेट अवे गो टू लोड केसेस, just model these two load cases, self weight and external load here like this. So it is like you learn any one finite element program and you should be able to, work on any of it.
आरएम में और इसमें कुछ सिमिलरिटी थी, दोनों ही तो अलग।
आरएम वालों ने ही तरीके से इसको डेवलप किया है, तो
दोनों ही हो रहा है।
आरएम नहीं है,
ओनर एक नहीं है,
डेवलपर्स।
दोनों ज्यादा एडवांस कौन सा आ रहा है? एडवांस नहीं, सोफिस्टिकेट। यूरोपियन कंट्री सारे आरएम यूज कर रहे हैं।
बहुत कॉमन है, इसको छोड़ यूरोप में तो यही चल रहा है।
या माइडस या फिर सॉफ्टस्टिक और ये वगैरह यूएस वगैरह में ज्यादा चलता है तो मार्केट
बिकॉन जो है उनका आरएम नहीं है।
मैंने पर्सनली आरएम ज्यादा यूज नहीं किया है, so I cannot really comment on that. ठीक है, so should we proceed?
yeah.
So what you just created these load cases, right, everyone? Okay, so I say okay. Now I need to model these loads. Now I give you an explanation of element loads and free loads. So you see that there are 3 types of your elements. One is point element, line element, and area element. Similarly, you've got 3 types of your load types as well: point load, line loads, and area loads. Under this, you see that free loads के अंदर भी 3 ही आते हैं: point load, line load, area load, volume load. These are separate categories. And element loads के अंदर भी ये 3 ही आते हैं, ठीक है। Now, what is the difference? So let us just try to understand. If I select this free line load, okay, click on this, and I say that it's an external line load. Intensity is 10 kilonewton per meter. I come here in model space and I say pick lines or curves, and I just, it says that there are more than 2 lines. AutoCAD का भी एक लाइन और स्ट्रक्चरल लाइन भी एक है। तो मैं बोलता हूँ कि क्लोज एंड इट आस्क्स मी विच वन यू वुड लाइक टू पिक. आई विल पिक एनी वन. स्ट्रक्चरल लाइन दोनों भी सेम ही है. ठीक है. नाउ व्हाट आई डू इज I go here, okay, and select this load and say CO enter, and or I say move M enter, okay, and move this load here by 5 meters. What has happened? My load has now shifted by 5 meters. So I could move the load. Now what I do is I copy this entire thing and place it parallelly at 50 meters distance here. Okay. In this case, what I do is instead of this line load, free line load, I go for modeling element line load. So I click on element line load and I choose here this line and I enter it. Okay. And I go to external load and I simply say, okay, my line load is modeled. Right. Now what I do is I select this load, say M enter and move it by 1 meter. So that load doesn't go anywhere. It doesn't go anywhere. It is, linked to the line. What I now here do is I select this line element, okay, and move it here by 15 meters, let's say. Line is here, but load is here. Now what I do is I select this line element, okay, only this line element, not the load. And I say M enter and say 15 meters. And load also goes with the line. As a result, if I now select this line, okay, and drag this line from here to here, longer one, my load also becomes strong. You get the difference between element load and the line load now, free load. So free is free. जिसके ऊपर वो रेस्ट हो जाएगा उसके ऊपर वो लोड अप्लाई हो जाएगा. लाइन लोड
क्यों है फ्री दिया क्यों है
बहुत फायदा है. फ्री का और लाइन दोनों भी इक्वली इंपॉर्टेंट है. ऐसा नहीं. यू नीड फ्री लोड्स सेवरल टाइम्स.
तो आपने ये जो किया था कि 5 मीटर आगे निकाल दिया था फ्री में, तो ओनली जो 5 मीटर विच इज से ऑन द टॉप ऑफ द बीम उतना ही आता है, आगे का नहीं. ट्रांसवर्स रिमूव कर देंगे तो देयर विल बी नथिंग क्योंकि नीचे कोई एलिमेंट नहीं है, टॉर्शन वगैरह सब
कुछ नहीं. कुछ लोड ही अप्लाई नहीं होता.
कहाँ यूज होता है कोई जस्ट रैंडम कुछ बता सकते
हैं. वेरिएंट कोड अप्लाई कर सकते हो. साइड कुछ भी नहीं. लाइन लोड. सो वेयर मेरे को जहाँ पे ऑटोमेशन करना है, जैसे मेरा एक्सिस बेस्ड था, वहां पे मैं आई गो फॉर एलिमेंट लोड, क्योंकि मेरा लेंथ अगर इंक्रीज हो गया ब्रिज का तो ऑटोमेटिकली मेरा लोड का भी लेंथ इंक्रीज हो रहा है. लेकिन अगर मैं वहां पे फ्री लाइन लोड यूज करता तो कोई ये नहीं था. अभी ऑटोकैड बेस्ड रेफरेंसेस जो है उसमें मेरे को ऑटोकैड के लाइंस ऑलरेडी अवेलेबल है. ऑटोकैड की लाइंस अवेलेबल है क्रैश बैरियर के लिए. क्रैश बैरियर ऐसी जगह पे आने वाला है कि वहां पे मेरा ऑटोकैड का लाइन रहने वाला, तो वहां पे मैं फ्री लाइन लोड लगाऊंगा. वहां पे मेरा एलिमेंट लाइन लोड लगेगा ही नहीं, क्योंकि वहां पे एलिमेंट है ही नहीं, स्ट्रक्चरल एलिमेंट. राइट. But if you ask me this one or that, it is not like that. It is as per the right usage कि वो टाइम पे आपको क्या चाहिए. हम देखेंगे उसको. क्रैश बैरियर का लोड है मेरे को, so that is right on top of my slab, but not on any. It's on my area element. It's not at the edge of the area element. लेकिन वो 250 mm का ऑफसेट डाल के वहां पे मेरा ऑटोकैड का एक लाइन ऐसा कर्व मूव होता है जाता है, तो मैं वो लाइन को सिलेक्ट करूंगा और मेरा फ्री लाइन लोड है वो उसके ऊपर लगेगा. Now, so you understand the difference between free loads and the element loads. So we are done with this. So what we now do is I just delete these things, go back, take it back to its original shape. So, and I simply export it.
नहीं अभी किया नहीं है.
अच्छा.
डेड लोड वगैरह कैसे अप्लाई होगा?
डेड लोड तो अपने को मॉडल करने की कोई जरूरत नहीं.
उसके लिए कुछ इनपुट भी
कुछ नहीं करना है, बस उधर 1 डालना है.
ओ वाह,
फैक्टर
लोड मैनेजर. ओके.
और आप फ्री लाइन लोड बोलो, लोड केस नंबर 2 सिलेक्ट करो. कुछ नाम डालने की कोई जरूरत नहीं, बस 2 नंबर डाल दो. 10 ही रहने दो, कोई बात नहीं. पिक लाइन सर्च करो.
के हिसाब से रहेगा।
हाँ वर्टिकल माइनस पीजीआर है ना,
माइनस
नहीं 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 पीजीआर लोडिंग ग्रेविटी हमने वो पहले डिफाइन किया, ग्रेविटी डायरेक्शन इज माइनस लोकल जेड, पिक लाइंस और कर्व्स, सिलेक्ट दैट लाइन। तो दो लाइंस है, क्लोज बोलो, इसमें से करो सिलेक्ट कौन सा भी एक, डन। ठीक है, अभी होता क्या है कि इफ यू मॉडल दिस, लेट मी जस्ट टेल यू वन मोर थिंग अबाउट दिस फ्री लाइन लोड। होता क्या है कि देर इज सम ऑप्शन ओवर हियर फॉर डायरेक्शन ऑफ प्रोजेक्शन, ओके, एंड हियर इज ऑप्शन फॉर रेंज ऑफ एप्लीकेशन। कभी कभी क्या होता है कि मेरा क्रॉस सेक्शन जो है दैट कम्स विथ केम्बर्स और समथिंग, और यू नो देयर इज सम गैप बिटवीन दिस, ये कभी कभी ये हो सकता है कि ये थोड़ा ऊपर है ऐसा भाई 100 mm लेट से। अगर आप यहाँ पे रेंज ऑफ एप्लीकेशन में अगर जाके बोल दोगे कि नीचे वाले 0.5 मीटर्स में मेरे को ये अप्लाई करना है, तो वो कवर कर लेगा। मैं भी लगा दूं लेकिन वो ऊंचे वाले तक ले लेगा।
बट वो ओनली वर्टिकल डायरेक्शन में करता है या एसेंट्रिक
हाँ उसमें भी वो इधर पूछा डायरेक्शन ऑफ प्रोजेक्शन ऐसे। इसका भी बहुत जरूरत रहता है, यू नो वेर एवर देयर यू नो केम्बर्स ऑल एंड ऑल।
सेंट्रिक लोडिंग देंगे मतलब है कुछ मेंबर रेफरेंस मांगेगा तो
मांगेगा रेफरेंस में वैसा भी कर सकते हैं।
अगर उस मेंबर रेफरेंस का सेंसिटिविटी रहेगी तो उस मेंबर को कराएंगे।
एग्जैक्टली, ठीक है। सो योर मॉडल लोड्स, हम इसमें प्री स्ट्रेस भी मॉडल करते हैं, लेकिन उसके पहले हम इसको एनालाइज करते हैं आपके लिए, ठीक है, और रिजल्ट्स को देखते हैं। आई एक्सपोर्ट इट, सो फॉर एक्सपोर्ट यू नीड टू गो टू दिस प्लेस, it says create calculation model by exporting the structure, generating loads, so on and so forth. I simply say okay, and I go to SSD, and I get to see something like this, a beam element. I can change the size of my support and hinges here like this. Yes, ma'am. Could you export the model? Error आ रहा है. What is the error?
ये लोड्स वगैरह नहीं दिखेंगे और लोड्स आएगा।
आप नहीं now also what you can do is you can go to home, you can go to graphics, वहाँ पे आपको लोड्स दिख जाएंगे। तो इसमें लोड केस 1 नहीं दिखेगा, अभी नहीं दिखेगा, एनालिसिस के बाद दिखेगा, क्योंकि वो it's coming man. What's clear? Okay. Problem for the level for minute. No. So what happens as soon as you export your model, okay, and in this Sofistik 2025, you straight away get to see this environment, okay, something called viewer. ऐसा कुछ देखने को मिलता है जहाँ पे कि ऐसा कुछ आता है, ठीक है। ये 2025 में आ रहा है। होता क्या है, व्हाट हैज हैपेंड दीस डेज, इफ यू वांट टू लेट्स हैव लुक एट योर लोड केसेस, ओके, तो ये जो लोड केसेस है, मैं जाता हूँ, सर पूछ रहे थे कि लोड्स कहाँ पे देखूँ मैं, तो मैं बोला सर आप यहाँ पे जाके ऐसे लोड केसेस आप देख सकते हैं, इसका एनालिसिस अगर कुछ नहीं हुआ, लोड केसेस एसएसडी में नहीं दिखते। तो द थिंग इज दिस एनवायरनमेंट is not interactive. That means you cannot select a beam element, double click, फिर उसको आइसोलेट करके उसके नोड्स पे वो स्टैड में करते हैं, हम लोग वैसे नहीं कर पा रहे। तो सम ऑफ द यूजर्स आर रियली हैप्पी विद दिस। जो ओल्ड यूजर्स है यही सही है वगैरह, एक फोर शीट है, डायरेक्टली रिपोर्ट बनता है वगैरह, दैट्स ऑल वन थिंग। बट व्हाट नाउ सोफिस्टिक हैज थॉट अबाउट इज कि हम एक इंटरेक्टिव व्यू उसको बना देते हैं। तो ये जो व्यूअर करके जो आ रहा है अभी, दिस व्यूअर दैट यू सी, दैट इज एन इंटरेक्टिव ग्राफिक्स wherein you will be able to see कि इसके ऊपर क्लिक करके कौन सा लोड कैसे, क्या नंबर्स वगैरह आ रहे हैं, MY MZ क्या आ रहा है वगैरह। बट इट इज स्टिल अंडर डेवलपमेंट और मेरे को भी पता नहीं कि उसका कितना लेवल तक डेवलपमेंट हो चुका है। थिंक टू हैव दिस इंटरेक्टिव ग्राफिक्स as well as that twin graph together, जैसे कि you get what I'm saying very clearly, right? So I'll say that अभी तो फिलहाल के लिए व्यूअर में कभी जाने का जरूरत ही नहीं, एटलीस्ट फॉर नेक्स्ट कमिंग 6-7 months at least I'll say, and we simply go to our system visualization. The moment we are here, we have got a task over here for linear analysis here. I double click on it and already there are 2 load cases which I have modeled. जितने भी लोड केसेस आपने ऑलरेडी मॉडल किए रहेंगे वो यहाँ पे आपको दिख जाएंगे। यू हैव एन ऑप्शन टू मैन्युअली सिलेक्ट द लोड केसेस कितने आपको रन करने वगैरह और अनसिलेक्ट। बट फ्रैंकली इन सॉफिस्टिक, फ्रैंकली टू बी ओपन इनफ, दिस इज नॉट द प्रेफर्ड अप्रोच। आपको अगर एनालिसिस करना है तो लोग बोलेंगे कि ये तो आप यूज कर ही सकते हो, नहीं ऐसा नहीं है, बट एवरीवन प्रेफर स्टडी। स्टडी गिव्स यू मोर ऑप्शंस। मतलब आपका बहुत बड़ा मॉडल है जिसमें यू गॉट 200 ग्रुप्स लेट्स से, ओके, क्योंकि सब आपका बैलेंस कैंटिलीवर है। हर एक जो आपका जो सेगमेंट जो एक्टिवेट होने वाला है दैट इज गोइंग टू गिव न्यू ग्रुप नंबर। यू गॉट सपोज स्प्रिंग्स व्हिच आर इनटू अदर ग्रुप नंबर। आपका कंस्ट्रक्शन स्टेज के लिए आप यू ऑलरेडी हैव योर टेम्पररी सपोर्ट्स इन योर मॉडल, और आपको सिर्फ एनालिसिस करना है फाइनल स्टेज का। वो केस में आप क्या कर सकते हैं कि आपका जो ग्रुप नंबर है सपोर्ट स्प्रिंग्स का, क्रेन्स का वगैरह वगैरह, क्रेन इज ऑल्सो लोड राइट, व्हाटएवर इट इज। सो आप बस अगर टेडी अगर यूज किया तो आप बोल सकते हैं कि मेरे को ये ऑफ कर देना, मेरे को चाहिए ही नहीं। जो ये इंटरेक्टिव ग्राफिक्स में इतना आसानी से वो कर नहीं पाते। अगर आपको एक अलग डायरेक्शन में स्टिफनेस ऑफ करना है तो आप टेडी में बहुत आसानी से कर सकते हैं। अगर आपको लेट से आपके पास स्टेपिंग लाइव लोड से जैसे आप स्टैड में करते हैं, इसमें मतलब माइडस में तो वो इन्फ्लुएंस लाइन बेस्ड होता है, स्टैड में स्टेपिंग अप्रोच होता है, इसमें दोनों भी कर सकते हैं। अगर आपका लाइव लोड स्टेपिंग वाला है तो उसमें आपके पास मिनिमम 1000 तो लोड केसेस होने वाले हैं वो केस में। तो इसमें अगर आपको 1000 लोड केसेस सिलेक्ट करने हैं तो इट्स टू मच। बट इन टेडी व्हाट यू कैन डू इज यू कैन से दैट लोड केस LC in bracket 1 to 40 with an increment of 1, तो 1 to 40 वो रन करेंगे। In place of 40 if you put 1000 with an increment of 2, तो आपको 1 3 ऐसा कर करके वो एनालाइज करेगा। मतलब वो जो फ्लेक्सिबिलिटी जो देता है ना वो, तो दैट इज इमेंस, दैट्स व्हाई people use that. Now what I do is I simply say here select all load cases and I say okay, and what I further now do is I get to see here in system visualization self-weight and external load cases. And if you go to graphics, you should be able to see these load cases here under this tree menu: loads, load case, self-weight, and external load, like that, right? Okay.
ग्राफिक्स में एक और बताओ रिजल्ट्स कैसे कहाँ दिखते हैं?
Okay.
अच्छा साइट में।
See graphics. I'll just give you a brief of this graphics. Graphics has got a tree menu onto the left hand side. इसके ऊपर this is one thing, okay. P and downward arrow is there, which has got 4 trees basically. System values. System value stands for अपने स्ट्रक्चरल लाइन नंबर क्या मॉडल किया, ग्रुप नंबर क्या मॉडल किया, क्रॉस सेक्शन क्या मॉडल किया, वो जो मेरा मॉडलिंग का जो इन्फॉर्मेशन है वो सारा सिस्टम वैल्यूज में आ जाएगा। ज्योमेट्री जो है वो सब सिस्टम में आएगा। जो सेकंड जो ट्री है दैट इज फॉर लोड्स। लोड्स के जो भी डेफिनेशन है आपके वो सारे लोड्स के अंदर आ जाएंगे। तीसरा जो है वो रिजल्ट्स, मतलब आप एनालाइज करने के बाद जो बेंडिंग मोमेंट, शेयर फोर्सेस जो मिल जाएंगे वो रिजल्ट्स के अंदर आ जाएंगे। डिफॉर्म स्ट्रक्चर के बारे में कुछ देखना, डिफॉर्मेशन वगैरह, तो लोड्स ये डिफॉर्म स्ट्रक्चर में आएगा। आप कुछ स्ट्रेस आउट कुछ निकालते हो तो यहाँ पे और एक टैब बन जाता है डिजाइन करके, वो उसमें आ जाएगा। आप अभी स्प्लिट से लोड्स देख रहे हैं, ठीक है। इनपुट लोड्स ऑल लोड्स देख रहे हैं, ठीक है। इसके अंदर फिर आपको लोड केस चेंज करना है, तो अब यहाँ पे लोड केसेस का दूसरा टाइप है, जिसमें आपकी जितने भी लोड केसेस रहेंगे, 1000 लोड केसेस रहेंगे तो 1000 विल बी लिस्टेड होगा। तो मतलब आप चेक कर सकते हो कि मेरे को कौन से लोड केस में कौन सा लोड देख रहा है। नेक्स्ट इज फॉर यू वांट टू सी रिजल्ट इन डिफरेंट फॉर्मेट्स, लाइक कि मतलब आपने एरिया एलिमेंट है फॉर एग्जांपल, तो आपको कलर्ड व्यू में देखना है, तो वो लाइंस में देखना है, वेक्टोरियल रिप्रेजेंटेशन में देखना है, सो ऑन एंड सो फोर्थ। नेक्स्ट इज रिगार्डिंग योर ग्राफिक्स, मतलब जो कितने पेजेस में देखना है, पेजेस को ब्रेक डाउन करना है 2 पन्ने में, 3 पन्ने में, सो ऑन एंड सो फोर्थ। ये क्या है, नेक्स्ट वाला तो मैंने कभी यूज नहीं किया, और डेटा बेसिस पे आप चेंज कर सकते हैं, वो करने की कोई जरूरत नहीं है। नाउ यू आर एबल टू सी द लोड, राइट।
इसमें
कुछ किया था आपका, नहीं हुआ था क्या? Okay, I'm coming. So what you can further do is just play with the results now. Beam elements, forces.
मेरे केसेस नहीं है,
आपने एनालाइज नहीं किया रहेगा।
नहीं एनालाइज करके
Okay, I'm coming.
don't worry.
So just go with the cases. आपका स्ट्रक्चर था, लेकिन that was not, मतलब दिख नहीं रहा था। That is the points. क्या होता है आपका, हो गया? देखना, वो तो जिस लोड सिस्टम वैल्यू स्टैंड्स फॉर कि उसका सिस्टम का क्या डेफिनेशन है ज्योमेट्री का, आपका वैसा।
मेरा एक ही लोड पे
तो
but वो वन है।
Okay, so you can simply, go through this Venn graph from, this place to that place and have a look at the results. Now what you can do is you can go and take a box like this. Okay, कभी कभी बहुत बड़ा मॉडल होता है, अपने को देखना है बहुत छोटी चीज को, तो there is option for a box. So I go to select boxes, box, and I want to see only this. It was very small. Select boxes, box, select this like this. So you can select box from here, or there is also option over here as well in this.
there is a
Where?
yeah. F.
Box. I never use it from here.
वापस कैसे जाती है रिटर्न?
आपको वापस जाना है, so you don't want to go to get out of the box, right? So you simply click on this structural limits बोलते हैं, just left of it. So this is box, so you just select this is box, and you want to go back, just left of it, it is structural limit. And as you know that this is an A4 sheet, so you can convert it directly to your. You can,
मैं कल आपको ने उसमें बताया था लास्ट
क्या
कि इसमें हाउ डू वी ऐड शेयर डायग्राम एंड
करना है आपको?
चीजें हाँ
ठीक करते हैं।
कैन डू दैट आफ्टर लंच आल्सो
अच्छा लंच करना, ठीक है, चले लंच के बाद करते हैं। So what time we start again?
अब बताओ आपको कितना टाइम लगेगा
So 1 hour break. आपका कितना रहता है ब्रेक यूजुअली?
बना रहे
ट्रेड सेंटर कहाँ है? यही बोल हाँ, यहाँ something called pantocatenary interaction. You know pantographs? रेलवे के ऊपर नहीं रहते पैंटोग्राफ? क्या पैंटोग्राफ रहता है रेलवे, वो
अच्छा
इलेक्ट्रिसिटी वो ऑब्जर्व करता है. So these guys are working on pantograph and the catenary, the wire above the interaction. So the train runs touching that pantograph, and it is analysis they do for कितना contact है, कब contact lose होता है, तो efficiency of the current being drawn, and how you can optimize the tensile forces in the cable element so that
this is for the design of the cable
yeah, design of the cable. क्योंकि केबल एक बहुत एक्सपेंसिव चीज है इन टर्म्स ऑफ
support of the cable
हाँ, तो मतलब ऑप्टिमाइजेशन, ओवरऑल ऑप्टिमाइजेशन कि उसका लाइफ स्पैन कैसे बढ़े, उसका वेयर एंड टेयर कैसे कम हो जाए, और जो करंट का जो इन फ्लो है उसका एफिशिएंसी कैसे बढ़े. और नथिंग टू डू विद स्ट्रक्चरल इंजीनियरिंग, but definitely it has something to do with finite elements and all of that. और वो कैसे कि cable sacks, right? So it is non-linear analysis, it is geometric non-linearity. It loses context, so then it comes into material non-linearity. ऐसा है, वो पिछले कई दिन से कर रहे हैं, लेकिन वो अच्छे रिजल्ट्स आते हैं. They're very close, 99%.
कौन कर रहे हैं सोफिस्टिक करता है यहाँ पे कंपनी कर रही है
These are electrical guys, electrical guys. But they are using Sofistik for that. Sofistik can do that very efficiently. So the results are very close. मतलब 99% ऑलमोस्ट मैच, लेकिन पिछले 4 महीने से 99% ही मैच है. उनको 100% वो रिक्वायरमेंट है उनका, कुछ कोडल प्रोविजन है, तो वो 4 महीने से वो हो ही नहीं रहा. आई एम नॉट ए इलेक्ट्रिकल गाय बट वो हर दिन लेके बैठते हैं और करते हैं. गोइंग टू देयर ऑफिस एंड आई विल बी बैक बाय 2 PM फॉर श्योर.
ठीक है लंच कर लो आपको थोड़ा
लंच करते हैं फटाफट एंड वी डू दैट. और आपको बीच बीच में ब्रेक वगैरह चाहिए तो वैसे भी बोलो. एंड सर यू प्लीज कम इन द सेकंड हाफ एंड यू